Okay, let's get this show on the road. Cool. Hello, everybody. This is stream number 427. I'm working on Serde, or Serde, or however you want to pronounce it. Custom serialization code in Rust. I was working on this yesterday, and I have gotten all the serializer done, and I'm in the midst of doing the deserializer. Maybe about halfway through. I have stopped right here, and this is to do. All right, getting right into it. Looks like the next thing I need to do is deserialize option. Okay. I have a feeling my phone is going to be waking up a lot today, because serialize sounds like Siri. No. Copy, paste, deserialize option. All right. Okay. Gosh, this was a lot clearer last night when I was working on it. Oh, I remember what I was going to do. I was going to copy from the serialization and then reverse it. That's right. So I need to find the one for option. Okay, so in the option it's none and some. Okay, so we should probably do the same thing. Like I should have a deserialize none. Yeah, okay, we'll just copy from here. And then turn this around. It's deserialization instead. And this is from. Hello, Nui. You're first here today. Okay, I need to swap the bytes with the expectation. So that's the bytes. This is the expectation. Hey there, LumaCode. You're here second in my stream today. How are you doing? Okay. Yeah, I need to put in a similar to what I did up here. I have to put in a type annotation. So option that, and I guess then I don't need the turbofish there. And this should be assert that deserialization is none, right? I'm pretty good. Unicode, thanks for asking. Hey there, Endurn. You are the third person in the chat today. Time to make your own Serde, whatever it's called. Yeah, I'm thinking it should be called Serde because you say serialization, so actually it should be Serde, serialization, deserialization, so Serde, Serde. That makes the most sense to me. If Serde is serialization, deserialization, serialization, deserialization, Serde. Okay, so for example, in this test, we're taking the byte stream of just a 0 byte and interpreting in that as an option, we should get none back. And then let me grab the sum example too. Here's, I think the first one we're doing that's a compound type, so it's a it's an option that has to have something in it. So what if I, just to make this interesting, what if I make this a U8? Could it be like French for, nah, I'm not gonna say that word. I know what that word is, Endorn. Okay, so this is the byte string. It goes here. The value, okay, I need to turn the value around, right? So this should be option U8. And it should be that think that's all we need to do, right? Wait a minute. No, I don't. I need to do a match. A match would be the easiest way. Matches. Deserialization matches the pattern sum integer 42. Okay, cool. Shitty word. All right, running the test. Not implemented yet, that's correct. So let me go over a little bit about my understanding of the D in Serde. Let me find the right page. I should have had this ready. Serde. Documentation, right? Actually, that's not what I want. I want the... Hold on. How come this is going to the same place? Oh, interesting. How do I get to... Okay, I'm confused. There should have been a manual page. This was leading somewhere different earlier. Oh, maybe it's this page. Home? Yeah, okay, here. That was right. Home page. Okay. Let me find the right place. Implementing a deserializer. So there are two traits that we need to worry about. One is deserialize. If we're just talking about the deserialization, one's deserialize, the other one's deserializer. My understanding is a deserializer is concerned with mapping the encoding to the Serde data model, and this deserialize is concerned with mapping the data model to the actual structure that you're deserializing. So the deserializer is what I'm doing now. It's, like I said just now, mapping the actual encoding to the data model. So it will be presented with an encoding. So, for example, the bytes. Well, actually, let's just do the option one. If the encoding is just a 0 byte, and I want that to be equivalent to a none option, and if the first byte is a 1, and then there's data that follows it, then that corresponds to a sum, where the data that follows is further deserialized, right? So the deserializer is just turning this raw element from bytes into its recovering the element sum 42 from the encoding. So how that is used to deserialize data structures, that's the deserialize trait we'll get into later. But right now it's just the elemental stuff. And these back market ads from Twitch are weird. Hey there, JT. Saw a weird ad, eh? Too bad I had no control over it, or very little control over ads. The only thing I think I'm allowed to do is turn on or off the pre-roll ads. And I can turn off the pre-roll ads if I manually run ads, which I hate doing. I just hate the idea of becoming involved in any way with advertisement. Okay. So what the deserializer, how it actually works is we tell the we make a deserializer from the encoding, and then we tell the type, in which in this case it's how do I say this? That, yeah, if I hover over this, see how it says it's a result option U8 error? It knows that it's going to be recovering an option U8 because we gave it a type type annotation. That's a type annotation here. So that option U8 is the T here. So the T is some type that we're deserializing. So the type that we're deserializing has to implement Serde deserialize. All of the built-in types like option and U8 and string and slice. They Serde, I'm gonna have to practice that pronunciation. Serde will provide a stock implementation of that. We have to make a deserializer to turn the bytes into that, doing our part, which is just translating the bytes to a data model. The implementation of this T is going to take that data model and turn it into the actual data. And the way that the two kind of go together is that this T type, this implementation of deserialize, implements what's called a visitor. And when our deserialized functions are called, they're given the visitor, and the visitor is supposed to receive the data model. So I'm choosing to make it really straightforward in that there's a direct one-to-one mapping between the data model and the what the visitor is given. So if we're asked to deserialize a character, we tell the visitor, hey, okay, you get a character. 64-bit float, okay, visitor, you get a 64-bit float. Like in the Serde documentation says, though, it doesn't have to be a one-to-one. You could have the model could be more complicated if you want than a simple one-to-one pass-through mapping. But we're keeping it simple. So in terms of option here, what I got to do is figure out if the data really is a sum or a none, and then that's what the parsing does, and then figure it out and give it to the visitor. So we're going to do visitor visit right, either none or sum, right, depending on what we get. Yeah, so I guess that means we need to parse it first. Let value equals self parse option. And then actually let's just match that sum value visitor visit sum. Oh, is it because it's a compound? We have to give it another deserializer? I think so. Yeah, so what if I have it return a deserializer? Yeah, and if it's none, it's just visitor visit none, right? Yep. And that can return a result, which is what we want it to return. Same thing with none, right? Okay. So I need to do the figuring out if it's an option or not, and if it's in something, I have to give back the deserializer. Okay, I think that makes sense to me. So parse. So next to here, function parse option mute self. Yes. So result D, where D is a deserializer. Same lifetime, right? Hey there, Togglebit. How are you today? I'm figuring out Serde. How to implement my own serializer. I'm choosing to call it Serde because serialization and deserialization, I pronounce serialization and deserialization. So that's Serde. Serde. I have to say it many times so that I can get into the habit of that. I have no idea if this is the hold on, I need to put a D here, don't I? I have no idea if this is what I want for the parsing or not, but we'll see if I can figure it out. Okay, so we're just going to look at the next byte, right? Let me copy from some of the code here. Right, I had something like this where grab the next character, and if it's something, then we're good. Right. So make the buffer, make an iterator for the buffer being the slice that we're deserializing. And I think I just want to do a match here. If there isn't an X byte, the value's been truncated, right? If it's 0, then it's going to be... actually, this would be an option, won't it? Yeah, it's going to be an option, an optional deserializer. So 0 is none. Anything else is some, and then I had to put in a deserializer here. I don't think I want to put self in there, but I'm not sure. Oh, what if we do this? What I had to do with the serializer when we have a compound type, what did I do? Oh, those are the tests. Why did I have to pick the hard one to start with? I should have figured this out last night while I wasn't streaming. Yeah, we had a sub, yeah. Here I could pass self through, but here we're given a mutable reference to self. I wonder if I need to turn that into an pass a what am I trying to say? Instead of a reference pass self, so like that. We can try this. So then it's just I need to actually in both of these cases I need to advance it. So let's do let next equal. If we get to this point, I'm going to want to eat that byte. So self buffer equals slice self buffer 1 and so on, and then match next. And then we would get some self. Oh, in any case, it's going to be an okay, right? All right. I can't do that. Isn't self a deserializer? Wait a minute. Hold on. I don't understand. Self is a deserializer DE. Oh, I didn't say we implemented it though. Should I just say self? Then it's not a trait, it's just self. I'm kind of going on a leap here. The trait-bound deserializer is a Serde deserializer is not satisfied. Following implementations were found. Mutable reference. Okay. Hey there, Red Sky One. You have no idea what's going on, but it's fascinating. Hey there, Kozar. So I'm implementing serialization, deserialization. So we can go to the top overview. So the Serde ecosystem consists of data structures that know how to serialize and deserialize themselves. So serialize means to turn a structure into a string of bytes or JSON or something else that can be sent over a wire or over a connection or saved to a file. Some kind of persistent representation of the data, right? That's serialize. Makes a data structure in memory persistent somehow. In my case, it's going to be a string of bytes to send over a socket connection, right? Deserialize is the opposite direction. You're given like some kind of persistent representation, like a string of bytes or a string of characters or JSON or a text file or whatever, and you want to turn it back into the data structure that you started with at the very beginning when you wanted, you took it and you serialized it. So the Serde framework supports all this. And do they give an example? Here we go. So an example, here's a structure with two integers in it. It's a two-dimensional coordinate. And the one of the features of the Serde framework is that it can implement these traits for you, the serialize, deserialize, so that the structure knows how to turn itself into a persistent, serialized form in the Serde data model. To get all the way to the actual format, you have to pick a serializer. So, it makes sense. Like, you might want to turn the point into JSON, or you might want to turn the point into a byte string or a text string. There are multiple things you could turn it into, but picking out the individual elements like the X and the Y, that is the same for all of them. So in their example here, they're showing to use a Serde JSON serializer to turn this point here into JSON. So given this point, you should get this JSON out, right? You can imagine that instead of Serde JSON, we did like bincode to bytes, or I think they just call it serialize. Instead of getting this string out, you might get some kind of binary representation, like maybe just 2 bytes, 1, 2 for X and Y, right? So I'm doing the similar thing to Serde JSON and bincode. I'm making my own serializer so that I can, given an annotated structure like this, that I can choose the exact format over the wire for the elements of that structure. So in this case, we're looking at, well, how, if we have something that's an option, how are we going to turn it into bytes, or actually how to turn it from bytes back into an option? So this parse option says, look at the next byte. Look at the next byte right here. If there isn't a next byte, we have an error. Value got truncated, right? But given that we looked at 1 byte, we remove that byte from the buffer, and then we look at the byte. If it's 0, then we're going to say that the option is none. If it's not, if it's anything else other than 0, we're going to say it's something. And then here's a deserializer that you're going to use to figure out what the data is inside of the sum. And here's where I just need to figure out how do we pass on that deserializer to the visitor. They want me to pass the deserializer by value, and I think that's what I'm doing, but I'm not sure. Yeah, there's my deserializer. The trait bound is not satisfied, it says. Let me get a... I might have to cheat and look at bincode's implementation. I was doing that yesterday, If you can't figure something out, look at another implementation of it. Cargo Clippy. Trait Serde deserializer with a lifetime D is not implemented for deserializer. Okay. The following implementations are found. Oh, okay. So there's implementation if we form a mutable reference. So if I say mute that, okay, then the error moves to here. Type annotations needed. Can I infer type for type argument D, declare on the associated function? Well, we know that the type is actually V, right? Oh wait, that was when I thought that there needed to be generic, but it doesn't need to be generic, right? And this should be mutable. Okay, error moves back down to here. Can't borrowed as mutable is not declared as mutable. Okay, let's declare it as mutable then. Now my error moves to here. Can't move out of self was just behind a mutable reference. Hold on, what? Oh, okay. I think I need to change this so that back to what it was. mutable reference. And I'll change this to mutable reference to self. And I'll have it, yeah, that still works, right? Okay. I'll figure this out. And then this just becomes Deserializer again, right? Okay, cool. All right, got it. Hey there, Riot Dev. Yeah, I think this will make more sense the further I go. Hey, it worked. All right, how about the sum one? This is the tricky one. I'm not sure if this will work. Hey, it worked. Okay, cool. So given the byte string 1 followed by 42, it does it in a two-stage thing, right? When we say we want to turn that from bytes into some option, it's going to run through and make one of my deserializers out of that byte string, and then tell the option, the T here is going to be option of U8. It's going to say, hey, I want to deserialize using that deserializer. And the stock implementation is going to say, well, I'm an option, so I am going to pass a visitor to deserialize option. And then we end up here, right? And then we're going to first parse whether or not it's something or nothing. So that's the outer shell of the option T. So remember, we're parsing an option U8, right? So that is going to be the... we're going to handle the option, the outer shell, we take our buffer, which again is a slice of a byte string, and we're going to get an iterator out of that, so I can call next, and so that's going to tell me if there is a next byte or not. If there isn't a next byte, we're going to return an error that the values have been truncated. But if there is a next byte, then we're going to change the buffer to be basically march it 1 byte forward. We can do this because buffer is just a reference, so we're not actually moving any memory, we're just moving a pointer. This is essentially saying move the pointer over 1 byte. Then, since we basically consume the byte that says whether or not the option is something or nothing, we look at that byte. If it's a 0, then the option is a none. If it's anything else other than 0, then the option is something. And then to parse the inside of this, we're going to return ourself, which is a reference to our deserializer. So the deserializer is still going to have in the buffer the rest of the thing we're deserializing, right? But we won't know exactly how to deserialize it because that's it's really hard to explain this. On the very outside of the code, right? We said it's an option U8. So this type Serde has an implementation for the deserialized trait. So it knows to first tell me if it's some or none, and then if it's some, it's going to say, okay, now tell me what the U8 is. So again, the outer one, tell me if it's something or nothing, is deserialize option. Then to tell it what the U8 is, we would go up to deserialize U8, and which I implemented last night off stream. That is very simple. We first parse it as a byte. Basically, take the buffer, get an iterator for it, look at the first byte. If there is no first byte, then it's truncated. Otherwise, take that byte and return it in as the value, as the return value after marching our buffer forward 1, right? And then it's going to take that byte and tell the visitor, hey, here's the byte. And at that point, we're done. Now, if this is something like an option string, then this 42 would be given to a different function. It would be given to deserialize string right here. And then obviously we would have a problem because my serialization for strings 42 would be the length, and then that would be the end of the buffer. It would say that it's been truncated. Hey there, laziest guy. I'm attempting to explain how in Rust the serialization de facto standard works based off of the Serde library or framework, the Serde framework for deserializing and serializing data structures in Rust. So if you want to read more about that, it's in the serde.rs website. So I'm implementing a deserializer today. So what do they, let's see if they give a better explanation than I have so far. Yeah, it's really complicated because there are two different traits, two different parts of the framework happening. The deserializer, again, is turning, let's see if I write this as a summary. Deserializer turns the encoding into the data model. So encoding could be raw bytes. Actually, let's say it this way. Encoding. Raw bytes, JSON, text file, whatever you want. You pick the serializer. All right. The deserializer, you pick the yeah. Exactly. So that's one trait. The other one is deserialize without the R. And that might be another point of confusion. These two traits look almost the same. It's just one is got the R at the end, the other one. Deserialize is recovers the data structure from the data model. So now you're going to ask me, what is a data model? Data model is, let's see if they give an, actually, I think they have, yeah, they have a page that actually describes what it is. It's an API by which data structures and data formats interact. So I guess, AKA data format. I don't know why I get preoccupied with formatting my own text files here. Hey there, Nightshade dude. I think I'm going to leave this around because we're going to get asked this a lot. So I should put also here, Serde is serialization, deserialization. It's the Rust framework for turning data structures, for encoding data structures, really. So the complete list would be, there's Serializer, turns a data model into an encoding. So if we're proceeding from at the top data structure, the middle is the encoding, and the bottom is the recovered data structure, then it would be serialize as the top, right? Transforms a data structure into a data model. And then the deserializer turns that model into an encoding, and then you're working with the actual encoding. You might be sending it over the network, you might be saving it in a file, whatever, but on the other end, you're going to want to turn that encoding back into the data model and then recover the data structure from the data model. So it's really important that I explain what the heck the data model is. So let me figure out the right words to use here. I wish they gave it a really good explanation at the top here. Hey, welcome back, Endorn. The Serde data model is the API by which data structures and data formats interact. You can think of it as Serde's type system. So I think what I'm going to say is the data model is an intermediate form of a data structure composed of elemental types which a serializer knows how to encode. You know, I really need to fold this and indent it because chat is overlapping it. Hey there, Resubaka. Hey there, Sarian. Need to have another look at this sometime. You had a go once for reading the format paradox used for their games, but only got as far as creating a token stream. Okay. Yeah, I'm revisiting it today. So let's see if I understand it well enough to explain this again. So from the top, Serde, I'm trying to pronounce it as in serialization, deserialization, so Serde. Serde is a Rust framework for encoding data structures. So at the top we have starting with a data structure. We go through the serialize. Trying to make a little diagram here. Actually, let's say data model, data structure. This might help if it's more graphical like this, right? So this is encoding. Data model, data structure. So this is the whole full life cycle, right? So encoding, for example, JSON, text, byte string, etc. So everyone knows what a data structure is, right? It's a type in a programming language which holds one or more values. Data model is some kind of intermediate format composed of elemental types which a serializer knows how to encode, so that the serializer doesn't need to know anything about the original data structure. It's basically given a sequence of elemental types that the serializer knows how to encode. So the serializer knows how to encode bytes, integers, strings, floating point numbers, option, tuple, etc. But it doesn't, I guess you could think of it as the data structure is food. Serialize is kind of chewing up that food into what we can then digest in the serializer to give us our individual nutrients, right? In this case, like we have the data, but it's been transformed in two steps into whatever encoding we want. The first step breaks down the data structure into elemental units that are strung together in like a sort of like a digested version of the original structure, and then the serializer just takes that and turns it into the encoding, and then the deserializer and deserializer just that turned upside down. Deserializer takes the encoding and then recovers the data model, like the elemental things. It'll say, well, here's a string followed by an option, and then wrap that into a tuple, whatever. And then the deserialize takes those and recovers the data structure from it. So my understanding is serialize and deserialize are tied very closely to the actual data structure. So in the Serde documentation, when they give an example, this struct point actually implements serialize, deserialize, either through derivation, or you might have a more complicated type where you want to custom implement serialize, deserialize for that structure. So these are tied to the data structure itself, whereas the serializer, deserializer are detached from the data structure, and they're more concerned with the actual encoding. So, for example, Serde JSON knows how to encode things into JSON, but it has no idea what a point is. Point doesn't have any concept of JSON, but it knows how to break down a point into its X and Y, right? So those combined together allow you to get from a point to a JSON structure. I hope that makes sense. I'm going to keep this around in case we need to go over it again. But as I work on this, when you see serializer and deserializer, you'll know I'm dealing with the actual turning in between the actual encoding. In my case, it's going to be a string of bytes. And the data model, which is just a sequence of elemental types, bytes, strings, options, that kind of thing. When I get up to talking about serialize and deserialize, then I'm talking about actual data structures. And there, for me, it's going to be the data structures I'm going to be using in my game. So, I don't know. I don't know. Should I save this as? I should probably save this as a note. Do I have? I don't have any stream notes in that project. Here, let's keep it here in the game. Stream notes. Serde. All right, I'm happy with that. What's the difference between a model and a structure? So, a structure is a struct. That's the easiest one to understand, right? The data model is if you take that structure and break it down into its elements. So, a data model that would make sense, a straightforward data model for a point would be integer, right? But let's say point wanted to be more clever and it wanted to encode its data model as a 64-bit integer where the top 32 bits are the x and the lower 32 bits are the y. An alternate data model for point would be a single 64-bit integer. You see how that works, Enduran? There are two possible data models I just came up with. A 32-bit integer followed by another 32-bit integer, and then another data model for this is a single 64-bit integer. Either way, the serializer doesn't care what a point was. The serializer either gets two I32s or it gets a single I64, and it says, okay, I know exactly how to encode those two sequences. So the data model is chosen by the serialize, deserialize, the structure, right? The serializer is a mechanical beast that just churns out JSON or bytes or whatever based off of the data model. Yeah, or 8 bytes. Or you could say like, you could say that the points are transformed into indices in a table somewhere. If the points are all fixed points that are known in a table. So let's say there's a table that struct point has of all possible points. Let's say you can only have, the only legal points are the points that exist in some table. Then the data model for a point could just be an index, a single 8-bit integer, right? If there are only 256 legal points. So the data model could be anything that the structure wants to represent itself in a way that the serializer knows how to deal with. Or a pointer, yeah, exactly. They go through more examples in the Serde documentation, right? So I just don't remember exactly where it was, but they talk about like the data model could be, maybe it's under data model. Yeah, so their example of something that's not straightforward is the operating system string type. A naive approach would be just to map it to a string of bytes. But they talk about a data model where you actually encode it as an option, knowing whether it's a Unix file system path or a Windows file system path. And then the serializer would encode that as a enum with two variants and encode Unix paths in a different way than encoding Windows paths because they have different rules. So yeah, want to read more about it? It's in the Serde manual. All right, so that long explanation out of the way, I just did option. So the serializer, again, it's this middle part here that only cares about going between our byte string, like encoding, and these elements. So a sum or a none or a byte buffer or a byte slice or a string slice or a character or a floating point number, right? We only caring about how we want to encode it. So X is encoded as its ASCII code. I chose for basically to keep the UTF-8 encoding, right? I chose to encode string slices as the length of the string followed by the content of the string. So this D is 13, and that's the 13 bytes that make up hello world, right? Same thing for byte string. So an empty array of bytes is just a 0. An array with 0 is length 1 and then the 0. Length 3 byte string is 3 and then those bytes. So very simple encoding, right? So what's next? Oh, we have some warnings. That didn't need to be mutable. Cool. I guess the next thing is unit. That's extremely easy. So how do we want to encode the unit type? Unit type is that. Basically, it's the void or the meaningless has no data at all. So this should be rather trivial, right? So I'm going to take this serialized test and turn it around. Let me just find it. Yeah, so for unit, I said we should just get an empty encoding. So we should have exactly the same thing, right? Unit should come out as an empty. If we to deserialize a unit, we would take an empty array and expect a unit out. From bytes, it should be okay if it's an empty array. We should get back out a unit. We have to actually say here it is the unit type. And then, yeah, there's no reference. Actually, this is silly. We don't even need to do that, right? Yeah. I do need to say it's the unit, though. Result unit. Okay. Yeah, so what I want to see is that these tests go into the code where I have it marked to do, so that we know that the stock implementation of the deserialize for a unit ends up going into our deserializer's deserialize unit, because we might have some need in our data format to actually encode a unit. And in my case, I'm not going to bother. It's just going to be visitor visit unit. Done. Right? So this should just pass. So it's a trivial case, since we don't actually need to decode anything. Then there's the unit struct. I think I want to have the same approach with that. A unit struct is where you define a struct that has no content, right? So deserializing a unit struct, let's derive the stock deserialize for that unit struct, and then we're going to want to recover it from nothing, right? So that is turning serializations into deserializations. Given an empty unit here, we should get back, if I say result unit struct, it should just be okay. And there's nothing, since there's actually no data, there's nothing we can really do with it other than make sure that it decodes correctly. But this should, basically it needs to exercise that it goes into my deserialized unit struct. And again, we're going to do the same visitor, right? A visitor visit unit, I think. And we're given the name of the unit struct if we wanted it, but we don't care about it, so I'm going to say we don't use it. Let's make sure that this works. Oh yeah, okay, cool. So I hope that I explained that well enough. I didn't have this understanding until like last night, so I might still be off a little bit. Those who know more about Rust serialization, you're welcome to chime in and help correct me. Or maybe suggest better ways for me to explain what I'm doing. Hey there, pink fluffy llama. What am I working on? I'm turning my game into Rust. I'm turning the implementation of my game from C++ to Rust. So I'm working on my serialization library. I don't know if I ever showed this on stream, but the way I send messages between the servers in my game from one server to another is through a socket, and the messages have to be serialized to go across a socket. And so, for example, what's an easy one to show? Integers, actually. How about string? So the way I serialize a string is I take its length and I serialize that, and then I just write the characters of the string out. Basically, it's a length first and then the bytes. So I'm turning that into Rust today. What sparked this change? People asked me what I thought about Rust, suggested I learn it. I took a month or so to learn it, and I was really, really captivated by it. It's almost like if I had known Rust when I started my game, I would have written it in Rust. So it's just something I want to do, you know. I'm making quite a bit of progress. I got all of my network infrastructure done. So I have HTTP client, server, WebSocket, all done. And I started working on the Rust implementation, and that needs the serialization library. So I'm like, okay, I'll do the serialization library, then I'll do the raft, and then I will have enough to bring up the game cluster. I'll need to rebuild the core of the game in Rust, though. But I'm actually looking forward to it because this is an opportunity for me to clean up certain things in the game. Like, I was using JSON format for everything. I have the opportunity now to completely eliminate that. So I was worried for a long time about how am I going to turn the game's internal state from JSON into something a lot more efficient, some kind of binary encoding. This is going to allow me to do that. You once asked a ninja if you could toss me one of those little stars. He said, "Shuriken!" Shuriken, shuriken. Good one, Mr. Balrog. And hey, how are you doing? Mr. Balrog, you're like the champion of jokes. All right, so we just did unit structures. What's next? New type structures. Neat. It's going to be the same kind of thing, right? Those are going to be trivial in my binary format. You are correct, Andorn. Mr. Balrog, it helps me out a lot by entertaining me with dad jokes. Okay, so this is deserialize. New type struct. So again, deserialize that. So a new type struct is kind of like where a unit struct is to a unit, a new type struct is to a non-unit. So it's basically a wrapper around another type. It's a way to give a type a new name, which is why they call it a new type. So it's going to be, I think, actually this is not quite the same as the unit structure because we actually have some content in there, right? So in this case, if we have the encoding of the thing being wrapped, and we tell it we want to deserialize it to the from result new type struct, we should expect the value 42 for that deserialization, right? Without that and, right? Oh, they're not comparable. Yeah, let's implement partial equal. And debug. Then we can debug it. There we go. And hey there, Silmith and Epic Unknown. Came in right at the same time. Silmith says, am I writing deserializers for my own custom binary format? Yes, I am, Silmith. Have I thought about using existing format like Cbor or Protobuf? I thought about using bincode, but I didn't like the fact that it was slightly different than the binary format I already have in C++. So I said, what better way to learn Serde and maintain the same binary protocol I already have in C++ than to make my own serializer? So I'm actually learning a ton by doing this, I think. Sold your vacuum cleaner, or it was just gathering dust? Good one, Endorn. Does Mr. Balrog have license to reuse that? Yeah, Silmith, I already had one written for C++. It's this serialization library, so for example, like Boolean. Boolean's a perfect one, right? I turn a Boolean into a single byte. If it's a true, it's a 1. It's a false, it's a 0, right? And I write that byte. Something more complicated, a vector, for example, which is the equivalent of a sequence in Rust. The way I serialize that is, where do I show that? I first write the number of elements in the vector as an unsigned integer, and then I tell each of those elements to serialize themselves into it. So since I already had this, I kind of wanted the same thing. The other thing was I had my own custom compact format for unsigned integers where I transmit 7 bits per byte, and the top bit is like a more bit, so that if it fits in 7 bits, you'll need 1 byte. If it's between 8 and 14 bits, then you use 2 bytes, etc. So I kind of wanted to keep that also, yeah. But the larger thing is that the making my own serialization has been a great way for me to really dive in and learn Serde, like just by jumping into the deep end. So here's an example of how I would want to encode different numbers, right? 42 is just 42. 255, though, has to go into 2 bytes because I reserve the top bit for the more flag. So here it's set to 1, here it's set to 0. You kind of see how that works, right? It is a trade-off between smaller integers take fewer bytes to encode versus larger integers actually require more bytes. So a 4-byte integer actually needs 5 bytes to encode if it's very large in my format. I count on the fact that most numbers are going to be small numbers. Yeah, but otherwise, the format I'm picking is pretty much the same as bincode. I haven't looked at CBOR or protobuf, but the one that I'm kind of modeling this after is called bincode. This one here. Bincode. So that's the closest one to my custom implementation that's out there. Theirs is a bit more complicated too because they have different options, and I don't need those options. So I don't know if they show it, but like there are different ways in which you can customize the encoding, and I don't care for that. 2 messages up. Okay. The rotation of Earth really makes your day. Good one. You also written a JS version of this, or have you made your C++ into a Node plugin done Webpack shenanigans? So for Pink Fluffy Llama, for JavaScript, anything that needs to be processed by JavaScript, I'm using JSON. So in my game, when it has to send data to the client, it always sends it as a JSON object. I've always been, in the last couple of years, I've been thinking about, well, when I need to optimize that to like a binary format, I'll have to pick something. And I haven't gotten to that point yet where I need to. When I need to, though, probably what makes sense is for me to have a JavaScript version of this Deserializer, or the serialization, so that I don't have to have 2 different formats for all the messages. They could just have one common format, and then the client could be able to understand it too. That's okay, Endurin. The jokes are fine. Thank you for the follow. A nice exercise to port it to Serde. Yeah. I mean, the fact that I already had this library, I mean, it just makes sense for it to fit into into Rust as a Serde implementation, right? And then I'll use it, but probably I'll be the only user because anyone in their right mind would probably use bincode instead. You know, I'm just a little crazy wanting to make my own. Okay, so we're on new type structure. Did I verify that that works? It doesn't, because I haven't implemented it yet. Right, so basically I'm trying with my unit test to exercise all of the Deserializer functions. So all the ones, until I have a unit test in place, they're all marked to do. By the end, I want to have no to-dos left. Every unit test exercise is every function should be exercised by 1 or more unit tests. Yeah, we all appreciate the jokes, Andor. That's you and Mr. Balrog saying jokes is adding to the stream for sure. Okay, unit new type struct, right? I think, don't we want to just forward? Don't we just want to call deserialize on the like basically tell the visitor to oh, they actually have a new type struct. Okay, cool. So that's just self then, right? And I don't need the name. Remind me of the Pink Panther. Lots of to-dos. To-do. I get that one, Endurin, but that might be a hard one for the younger folks to get, you know? You have to know the Pink Panther song, right? To-do. New type struct, a variant, is that next? New type variant. Wait a minute. There's no new type variant. For deserialize, how does this work? Interesting. Okay, I guess it's handled differently. So the next one I need is sequence. All right. You don't have a case door on your computer because you don't want Windows. All right, I can appreciate that one, Pink Fluffy Llama. I can. Sequence. All right, so I'm trying to leverage the parity between serialize and deserialize by taking unit tests for the serializer and just reusing them for the deserializer. We just need to flip the value and the expected around, right? And then serialization becomes deserialization, and 2 bytes becomes from bytes. And here we need to be clear on what we expect. So we expect out of here a vector of characters, right? Yes. So this should hit the deserialized sequence, and it does. Great. See, this is where it gets more complicated, right? To deserialize a sequence, I'm going to want to deserialize first the length. So that would be let length equal self dot parse U64. Depends on what I did in the serializer. Serialize sequence. I did U size, but that effectively pushed. That was actually used by U64, right? Yeah. So I think I want to clean this up. I don't want to use the name U size anymore in serialize. Thank you for the follow, by the way. Computer is like a wigwam. No windows, no gates, Apache inside. All right. So yeah, parse, there's no maximum. That can error out. So given that, we have a length, which is U64. So then I kind of want that as a size, though. Oh, I'm going to have a whole bunch of these truncation things. Is that why in the serialize I made it U size? So I wouldn't have to deal with this? Okay, what if I have a helper to do that? Let's make a helper. So near parse... Near here, right? So function parse usize mute self returns the result usize. It's essentially just going to call self parse u64 none, and then question mark as usize sum or okay. And then I'll deal with this warning here by suppressing it. Cruel suppression of warnings incoming. Wahaha. Cruelly suppressed that warning. Okay, moving on. Yes, so given the length, it's now U size. How do I want to deal with that? I want to do a loop, don't I? So for... I don't need the loop variable. In 0 to length, visitor dot visit. Oh wait, I'm doing this wrong. I need to do visit sequence, don't I? I need to provide a sequence. Sequence access. So that's going to be self, right? Or it's going to be a wrapper around self. And without this loop, right? I think I want to move this code around. This code is going to be moved, right? So it's just going to be that. Without the to-do. Trait bound is not satisfied. Okay. Is that because I didn't implement seek access? Let me find where we do that. Oh, I never did. Okay, let's do that. I don't know if I'll need another structure for this, because I might need to encapsulate the length somewhere. So this is similar to the Serializer. Wow, this is a long trait. We'll have the same lifetimes? I think so, right? The A lifetime is for the reference to the deserializer. The D lifetime is for the deserializer itself. Serde D Sweak sequence axis D for A mute Deserializer D. Implement missing members. Next element seed. What is that? I might need to cheat and see how bincode implements this. I don't remember how this works. Yeah, I think I'm gonna have to cheat. So, if I remember right, I still am pulling in bincode just so I can cheat and look at their implementation. So, let's just go on the assumption right now that I need that. This result goes away because of how I define result. So just leave that to do, right? It should compile now. First, before I do bincode, let me see where this leads me. Yeah, it leads me into next element seed. I have no idea what we're supposed to do there, so let me switch to instead of calling that, let's call bincodes deserializer. Select deserializer is bincode deserializer. Or is it just bincode deserialize? And then the bytes, yeah. So that's value. So it's deserialization. And I don't need this, right? Okay, and that doesn't need to be mutable. Cool, so then I can see where that leads me. So, still having my buffer? Actually, what happens if I just run this? Yeah, I get an error. So that's not how they encode a sequence. So just click into that and see where it goes. Oh, I remember. That's why I had trouble finding where things were. So what I did was I pinned stuff. There we go. I did this last night. So I can go look for deserialize sequence. It's not familiar to me. Is it in mod? Ah, here we go. Okay. Okay, so they do decode the length first. And then they delegate to deserialize tuple. Okay. Why is that going to my code? It shouldn't go to my code. Okay, here we go. Okay, so they have inside of that function, they have a seek access. All right. And what do they do for the next element seed? Oh. The seed? I don't know what the seed means yet, but they do keep track of a length. And every time next element seed is called, they decrement the length. And when it gets to 0, they return none. Okay. And then while it's not 0, they go through a Serde stock thing to deserialize with the seed and the deserializer to get the value out. I need to read what the seed means, I think, to understand where this is going. Seed in Serde just means state. Visitor trait. Driving a visitor. Oh yeah, hello, Muzin. How are you doing? Yeah, just learning about it. And Narragera, hello. I remember seeing something about seed here. Was it under implementing a deserializer? I would prefer text over code if they have it. They talk about it under data model? No. I don't suppose that we'll find, if I'll find the page I was looking at yesterday. Maybe it was under structs and enums? No. Arrays and values without buffering? Nope. Oh, maybe it was through here I found it. One level up. Deserializer, maybe? This is where we just were. Yeah, that's where I was looking at. Is it under the D module? Okay. Stateful form of the deserialized trait. If you ever find yourself looking for a way to pass data into the deserialized implement, this trait is the way to do it. One example of stateful deserialization. As one example, consider deserializing a JSON array into an existing buffer. Using the deserialized trait, we could deserialize the JSON array into a vector, but it would be a freshly allocated vector. There's no way for deserialize to reuse a previously allocated buffer. Using deserialized seed instead makes it possible as an example below. Okay, it's like building a vector one element at a time. Or then maybe they'll explain what they mean by reuse a previously allocated buffer. In practice, the majority of deserialization is stateless. An API expecting a seed can be appeased by passing phantom data as a seed. Okay. That's okay, Selmith. I'll give you a point anyway. Normally, deserialize is stateless, deserialize seed is stateful. If you're familiar with the iterator trait, deserialize is like map collect, and deserialize seed is like scan or fold. I get it. So I don't need to use it. They're just using it here because they want to hold on to some state. Hey there, Radon 90. I'm doing Serde. Serialization Serde. Serializer deserializer code. I'm curious to see what deserialize for deserialized seed does. Because that's a... Oh, that's not a trait. This is a trait. But that's a method of a trait. Yeah, required method. Oh, they're just... Okay. They're just calling it through the trait directly, but it's really the seed that does the deserialize. I see. What are they putting in this seed? I kind of don't understand what the seed has in it. Okay, the seed is some T. The T is what we're getting back out as the value. Oh, access. Okay, so they are passing in a wrapper to the visitor. They're taking the deserializer and the length and putting them into a wrapper. So I don't need to use this. I don't even see what the state is. What's in the seed here? In the example C is just a wrapper over a vector that adds each new deserialized element. Where though? Oh, wait. I get it. I need to have that too because the seed is given to me. Yes. So, I was looking, yeah, that's what led me into this in the first place, right? To implement seek access, they're going to give me a seed. So it's Serde's framework that needs to hold on to the state, not me. I just need to go through that seed. Okay, I get it now. So they're building the vector, not me. I'm providing the elements of the vector by telling the seed to deserialize the next value. I get it. Okay. So I'm going to want the same kind of thing. I want to have basically just move this into sequence for now. Yes. Right about there. And I will want to parse the length. But instead of me doing the loop, they're going to do the loop, right? Struct. What to name the thing? Seek? Because I am lazy. So that has the deserializer in it. This can be lifetimed, right? Yes. What's the full type? I can just say self, right? Can I say self here? Length is a usize. All right. Then I wouldn't need this lifetime if it's just self, right? Recursive has infinite size. No! Yeah, I can't say self there because it would be infinite in size. Length's all the way down. That's the type that we're dealing with. So I think I need both. So I need both an A and a D. Right? And let's catch up with chat. Yeah, that's what I was thinking, Musin, that of it could have been a turbofish. Yeah, they're calling the function through the trait. Yes, they could have been done with seed.deserialize. Yeah, I don't know why they didn't. See a lot of qualified stuff in Serde to make it more obvious which trait is being called. Okay. Yeah, just not used to that, I guess. Have you seen the forward to deserialize any macro? I saw a few macros, but I skipped over them because macros still scare me. Self refers to the current type, so self, yeah, the self is contextual. Yep, that's what what I realized when it said infinite. I'm like, oh, it must contain itself. Okay, so I want this for that then. Why is it giving me warnings? Oh, because of, yeah. it says, please, it's telling me please do that before my code. There we go. All right, so then what I want to actually give it is a seek. D is self, and length is length. Cool. So then they do the loop for me, and then I deserialize through the seed, but I have to be careful about the this length. So I wish I hadn't cheated and looked at bincode's example, because I wanted to do the exact same thing. But let me try to do it without... Let me clear my mind so that I don't remember exactly what their implementation was, and let me do it in my own words, so to speak. I want to say if self.length is greater than 0, else none. And I want to wrap this all in OK. And I want to say self.length minus equals 1. And I want to say sum... Well, actually, do I go through the seed for this? Deserialize. Self. Here's where I'm not quite sure. I don't want to cheat. I want to try to figure this out. Alternative types. So I need to say sum. Okay, that's not quite right. Okay, what? Yeah, I click on that. What does it want? It's not even bringing me to the correct place, is it? I guess what I want to do is look up deserialize seed again. Actually, we were just there. So I just need to pass it a deserializer, which is AD, which in this case it is wait. It's just any deserializer, so self should do, right? Oh, wait a minute. Self dot D, right? And then we're going to run into this weird thing about it. We can't move it out, so I do a mute star, I think, to fix that. There we go. See, I think I figured it out. This little weird construct I learned from actually looking at bincode, and I don't quite understand it, but it's like, if D is itself a mutable reference to the deserializer, we have to dereference it, but then if we want to deserialize through where the D is again a mutable reference, we have to then extract another mutable reference. It doesn't reborrow automatically. I know that that's correct because that's what bincode does. Yeah, see that? They do the same thing. Self.length.checked sub. I'm checking it myself. That's what that if is there. That's what the if is for. See, not even bincode does a checked sub. Are you saying I could combine the if? So I could be smarter than bincode and do a checked sub? That's actually, we could do that. Without the deref in the middle. It won't work because then you'll get a reference to a reference. It's going to say mute is not like we got two references instead of one. We only want one. Like, yeah, the whole thing breaks down. It's really weird. Deserialize isn't implemented for mute. Yeah, exactly. So you guys kind of see how this is maybe going to be impossible for someone new to Rust to understand right out of the box. I almost kind of want to make a video explaining what that means when you see it. When you see reference to mutable pointer of something, don't be scared and don't run off screaming. It actually means something, and I wish I could describe it now, but in my future video I'll try to. Yeah, what's really weird, that this is what I think I got hung up on trying to implement this the first time. My implementation check this out. This will really throw you for a loop. We're not implementing deserializer for my type. We're implementing it for a mutable reference to my type. How often do you see that for a reference to a type? Usually when you make a struct foo, you're used to saying like implement, I don't know, implement bar for foo, right? How often do you actually see that instead? Right? And then of course you have to say that, and then that. How often do you see that? Hardly ever, right? I mean, it looks gross, but that's essentially what we're doing here. And I believe the reason why we're doing that is because a lot of these methods have owned self, right? Which means that it's going to consume self. If we didn't do it with reference, we'd be in trouble. We would lose ourself. But being a reference, we can work around that. And I think it all came down to this reborrow problem. If the deserializer wasn't taking a reference in the first place, we would end up consuming self, and we would not be able to. I don't know how to explain it other than that it would start the borrow checker would say you can't move out of self. You can't do that. It's a nice pedagogical question. Why is it mute t and self and not mute self? You mean why is we implementing it for a reference and not having instead a reference here? My answer to that would be that trivial deserializers might not need a reference. They could consume self. That's my guess. So this is the least constrained for that's not the right word. This is the least how do you say it? It enables you to make a really simple, trivial implementation that doesn't need to mess with references. So you can make a deserializer that has no references at all. It's just consuming self constantly. But we can still opt into making our deserializer by reference by implementing the trait on the reference itself, not on the type, not on the structure. That'd be my guess. Musin can tell me if I'm right or wrong. Pretty much, your question was more about the type system, but that's correct. It also lets them have a single trait. Well, for deserializer, they have the single trait, but what about for the serializer, where they have a whole bunch of traits? Actually, those aren't traits, are they? They're types. Do you count these as traits? I kind of think of them as sub-traits, because when we can't just implement serializer, we have to implement serializer, and then it's like 8 different types. Yeah, but they're almost the same burden, right? In order to implement serializer, we have to implement the associated types as well. Basically, disjointed generic types. Yeah, I guess you can also, I've heard the word facet used in years past. These are facets. So in my case, they are self, but you could also just make other structures which hold on to the serializer with other data. But yeah, this is like, I feel like I'm getting into code that's more advanced than my capabilities. It's kind of scary. Hey, I should be able to pass my unit test now, right? If I did that right, I think I did it correctly. Let's see. So I need to go back to using my deserializer. Run. It passed. I got away with it. I got away with doing something I had very little idea about what I was doing. All right, cool. So then tuple's almost exactly the same thing, only we're given the length, right? Yeah. I can see why now bincode implemented sequence in terms of tuple, because they're the same except for the way we get the length. All right. So let's pull in the serializer, and then I'll reverse it. Here's the tuple one. Hey there, Lazy Guru. Hey, I'm on a roll, Lazy Guru, implementing this super complicated code, and it's actually passing unit tests. I feel like a friggin' superhero right now. Deserialize, so from bytes instead of 2 bytes. ask me to explain it, and I'll try my best. I have made an explanation note. So for those who haven't been here over like half an hour, let me give another quick intro based on these notes that I took. I am implementing a serialization deserialization library. In other words, Serde, which is the specification for it is like a pseudo standard in Rust. It's the framework for encoding data structures. So let's say, for example, you have a data structure and you want to encode it to send it over a connection on the network, or maybe you want to save it in a file. Like maybe you want to save your game and your game is a huge data structure. You would use something like Serde to take all the data you have in memory and turn it into something you can save in a file or send across the network or whatever. It could be JSON, text, bytes, strings, whatever. And then on the other side, recover the original data structure. The framework does this in a two-step process, or a four-step process if it's a full loop. But if you're just going data structure to encoding, it's just a two-step process. You first go through the serialize. What word? You go through the serialize mechanism, which transforms your data structure into a data model. And what is a data model? It's an intermediate form of the data structure. It's composed of the elemental types, which a serializer knows how to encode. So it's two types working together cooperatively. You have a serialize, which is tied, it's an implementation tied to your data structure. Basically, the data structure gets to determine this itself. How should it be turned into the intermediate format, right? And then taking that intermediate format, it's handed off to another agent, which is the serializer, which is tied more to the actual encoding type. So that the encoding type can be independent of the data structure types, right? So it knows how to turn this data model, the sequence of intermediate elemental things like strings, arrays, that kind of thing. Essentially the pieces of the data structure somewhat digested into easier to handle elements, and it knows how to turn them into whatever encoding you want. So I'm right now implementing the deserializer, which is taking those the encoding that I picked. For me, it's a binary sequence of bytes, and turning it back into the data model, which then will be used by the data structure again to reconstruct itself. Hey there, Dr. Padawan. Okay, so my encoding is raw bytes today. My data model is, right now in my unit tests, they're very simple data models. They're one-to-one mappings. So, for example, a tuple here, the data model is built into Serde. Basically, the data model for a tuple the tuple is an element, so it's a one-to-one. So we're going to convert from bytes and expect this tuple back out. We're just doing the deserialization, so the data model is the tuple. How do we get to the tuple from this raw bytes? That's what my code has to determine. And we need to be specific about the type here. We want a character and a character, right? And no reference needed there. So, running my test, it's going to say we didn't implement something, because I didn't implement how do we deserialize a tuple. So, it's essentially the same as deserializing a sequence, except that we do not need to parse the size. We know the size of a tuple. It's known at compile time. So, I'm going to cheat and take this code here and simply copy-paste it, just for a second. And then get rid of the length assignment. And then make sure that this compiles and runs. And it passed. Yes. So I'm going to go back to that, and we'll rectify the copy-paste problem. So tuple and sequence are almost exactly the same. The difference is that we know a priori at compile time how many elements are in a tuple. For a sequence, we don't know. So that's why we had to put the actual length at runtime in the encoding. Since they're the same otherwise, what we can do is just calculate the length up front and then delegate to the other function. So now that we know the length, we can just call self deserialize tuple. Am I calling this wrong? I think just autocomplete is confused. I think it can just do that, right? And then delete all these extra lines. Maybe not. Why can't I do that? I don't get it. Oh, because length first and then visitor. There we go. Sometimes the compiler errors don't help me. So that still passes, and this still passes. Cool. So I know I glossed over it now. If you weren't watching me write this, the way we deserialize a tuple is the visitor is provided by the deserialize. So if we are the deserializer, and we're going to hand the data model to the deserialize, that the way we hand the data model is through the visitor. So the deserializer takes the encoding, converts it to the data model, and then passes it off to the visitor, which the deserialize provides. So we're going to tell the visitor, we're going to give you a sequence, right? And we know the length of the sequence. And we're going to say, use this deserializer, basically use ourself to deserialize the individual elements. And we have to provide one value which contains all that information, right? And it goes through that one value. It has to implement this special trait, sequence access. And what it's going to do then is internally it holds onto some state, which they call a seed by convention. Seed, state, same thing. I just learned this about an hour ago. And it's going to call this for in a loop, length number of times, right? And so we need to make sure that we have to remember the length. And then every time they call us, we need to decrement that length. And as long as we have more values, we tell the seed to deserialize using our deserializer, which we held onto, the next element. And then when we get to the end, none marks the end. But your check sub comment was that check sub returns an option. Yeah, I know, Musin. I just haven't optimized this yet. Let me give you a point. Yeah, so what Musin is saying is that don't need this if statement because we can just do this alternative way. We can say, okay, self.length dot check. I have to import a trait to get checked sub, right? I need to pull in what is it? That it's not helping me out. Checked sub requires a trait, doesn't it? You don't need a trait, it's built in? I wonder why it's giving me trouble here then. Is it just the autocomplete? So when autocomplete gives me trouble, what I do is I'll start doing that stuff, and then yeah, I just need to ignore this. I need to look at the manual. I ignore the autocomplete for a second. Right, so it's going to return me the option like Musin said, and I can just provide one there. And then we want to chain that with returning that. So I want to do a map, I think. We're going to want to map the length, which we don't care about, to calling this. Oh, that's fallible though, so hold on. I have to be careful here because we have to do that outside, which means we're going to map it to a result. So I think I need to turn this into an OK and then map it. Or just do OK. That work? Almost. I think I'm pretty close. Okay, I need to refer to the cheat sheet, which Musin found for us all. There it is. Okay, option. I have an option. I want to, if it's sum, I want to go through something that can give me a result. It's here somewhere. I just need to find it. Is it it's okay or no, but that's not exactly right. Hold on. Maybe I'm thinking about this wrong. If it's something, I want to call something which might fail, in which case I want to return an error. But if it doesn't, I want to repackage as an option. So I do want to go from an option to a result back to an option, I think. Yeah, but I'm trying to do it myself. So I'm not gonna look at Musen's answer because he's probably got it right. I'm gonna try to figure this out for myself because I learned better this figuring it out myself. I beg your patience while I practice here, and I look at the cheat sheet. Cheat sheet is not cheating, despite the name. I thought it would be or okay or okay. Where is okay? It's a pocket reference. That's right. I think it's okay. And then is on result. To go to the result first. See, you guys are telling me the answers, but I want to figure it out myself. I'll start looking at the answers if I get stuck. Right now, I'm just still exploring this again. I think I want map. And then the option will have a result in it. Yeah, I think I want map here, right? Let me put it on its own line. We first want to map it so that here we have an option of I don't care. At this point, now we'll have an option of result of it would be option T value. It'd be option T value, right? No, it would be a yeah, it'd just be a T value. Oh, don't I just want to transpose it then? Yeah, don't I just transpose? Because I want to turn that option result into a result option. Maybe not. Expected option found result option. Oh, just remove the okay. There we go. Did I figure it out? Let's look at the answer. Let's see what people wrote in chat. So self-len checksub map transpose. Yeah. So I got what Musen wrote about 4 minutes ago. It took me about 5 minutes to get to where he got in like that. The important bit is that checksub doesn't mutate the value. Oh, it doesn't? So I need to store it back in there, right? you're right. I need to store it back. So then I would have to do two things in here, wouldn't I? I would still need to do length subtract 1. Yeah, it just returns the new value which we don't care about. So isn't that less efficient because, well, okay. It's either way we have to compare it and then subtract. This you can think of as a comparison in the form of a subtraction that told us that it wasn't 0. I'm inclined to keep the original because it's more clear what's going on. This, someone's going to look at that and say, what the heck are you doing subtracting twice? Oh, good point. Good point, Musin. They give me the new value, so I could just reassign it. Then that makes more sense. Now, when I look at this code later, I'm not going to see 2 subtractions. I'll see 1 subtraction, and then if I know what check sub means, I'll know that we go into the map if it wasn't already at 0. And then that we get the result of the subtraction and we're storing it back in there. Okay, yeah, I like it. All right, let's go with that. I should first make sure it actually didn't break anything. So this is the tuple test, right? Run. Yep, still works. Serialize should also still work. Cool. All right, great. Do we have tuple struct next? Looks like we do. Tuple struct is going to be the same as tuple, right? My serializer doesn't care about the field names, so it's just going to be another one of these simple tests. Oh, I've missed some chat also. Let me go back up in chat and read it. Hello, Grumpy Game Dev. I just saw your chat. Hope you're having a great day. Okay, as a result, it does result to option, right. So I need to go option. Basically, I need to flip the option in the result. Tell it the error type. And give an error value producer in case you got none. Otherwise, how would it make result out of question? It's not the answer, right? It would be transpose, yeah. I mean, when I saw that we had an option result and we need to get to result option, I immediately thought of transpose. Because transpose is just one of those really cool functions you hardly ever get to use, right? How often do you go from option result to result option? Not very often. But when you do, remember transpose does it. It's just an explanation of why I have OK or else and no symbol OK for option. Oh, right, yeah, I see what you're saying, Silmith. Yeah, the OK or OK or else is how to provide an error in case of none, yeah. Is there a bind? If you're talking about, if we're in the middle of this Grumpy Game Dev, we're in the middle of talking about option and result, I don't think they use the term bind. They use these other terms that have to do with like combinator logic, you know, and then or else, that kind of thing. And then they use words like okay and what's the other one? Unwrap to signify success and failure and what to do when you fail, that kind of thing. So they don't use the word bind as much there. The important bit is that check sub doesn't mutate the value exactly. Okay, I think I caught up to that. Teaching people about transpose is your new favorite thing. Hey, we got to use it. I used it only because I recognized that the opportunity was there. Yes. The longest time you had no use for the ref type in F#, now I use it all the time, mostly in unit testing. That's cool. Map is a monadic bind, if that's the bind you're talking about. This term monadic, monad, you know, I spent about an hour trying to research that, like what that means. I just ended up in a black hole of math. I could never map it back to concrete usage and meaning in engineering. So if someone has an article that actually explains what a monad and what monadic means in practical terms that I can understand, then I'll give you a bunch of points because I still haven't found it. If you're talking about C++ about giant bind or JavaScript bind, then that's just making a closure. Oh yeah, a lot of these because a lot of these are functional, they take closures. So that's what whenever you see where is it? In like this. Map takes a closure. It takes a function object or functor or closure or whatever, lambda, whatever you want to call it, that it will call if the option has something in it to convert that something into a different type. So mapping to a different type if it's something. If it's none, it bypasses. All right, so I need from here, right? And, yes, I do. I want to turn serialize into deserialize here, right? Deserialize. My phone keeps activating because I have an iPhone and it keeps thinking I'm saying Siri when I'm not. Don't wake up. All right, so we're going from this byte string into accords this time. And will I have to be... oh, right. In order for this to work, I have to do partial equal and debug, right? Debug is for when it fails to be equal, and partial equal is so that we can actually do the equal part. So this is swearing the lyrics, but what is this about? Yeah, but that's a different kind of monad, Grumpy Game Dev. Thank you for that follow. There's a huge meme about trying to explain monads to non-math people via blogs. Well, and then is more closer to just do. Yes. Rust cheat sheet, thanks for the tip. Hey there, Dragon Soul Touched. You can thank Musin for that. Musin found the that cheat sheet. Musin likes to work on random projects in Rust and knows a lot more about Rust than I do. And also there was a companion to that, which is cheats.rs. This is a really handy one, though. A monad is just abstract representation of computation. Yeah, for me, I have difficulty grasping abstractions. I'm a hands-on learner. I need to actually get my hands into things. So abstractions are difficult for me to digest. Hey there, Peak. Do is syntactic sugar on top of a monad bind. Yeah, I'm missing fundamental understanding of what monadic means to understand that. That's the problem. Whenever I start looking up like blogs and like Wikipedia about monad, it's almost like it's self-defining. In order to understand monadic, you have to know what a monad is. Okay, what's a monad? It's something that's monadic. It's like, I'm gonna hit my head against the wall. Hey there, Kamundi. Talking about burritos. That's a different word. If you look up elevated types, you get a little further along. Okay, you only understood monad when you started doing Haskell. See, maybe that's it. Maybe I should just wait until I get to Haskell, and then I'll understand it. And until then, it'll just be some kind of mystical thing I don't quite understand. Okay, let's run the test. If you don't know what we're doing, I can stop and explain it again. But basically, we're doing deserialization, which is turning a encoded form of data into a data structure. Okay, and I want my unit test to find all these points where I haven't yet filled in the code, right? I think for tuple structure, we just want to delegate to tuple, right? So let's just do that. Basically tell the visitor that it's a tuple and that I don't care about the name at all. And then that should just work. I hope. Yes, it works. Perfect. Mon singular, die multiple. Oh, is that a joke on monads and burritos? Monads are like burritos. Okay. Thank you, Kamundi. And who mentioned burrito first? Commodity, yes. So, that will be when I'm eating lunch later. There's also bananas. Okay. They're making me hungry. You know, I haven't had lunch yet. You like that one and introduces it? Okay. Thank you, Narigara. Anything that'll help me understand it is appreciated. So let me grab that link. But I need to actually have lunch when I'm reading these because I'm just going to get hungry if I read food analogies. Don't forget spacesuits. Oh, bacon-wrapped monads. All right, I gotta move on. What's the next thing we need to deserialize? Maps. Okay. How did we serialize maps? Okay, that's the test for it. Right, it was the number of key value pairs and then just a sequence of key value. That's what it was. That's how I decided to do it. So deserialized map will be the same thing. First read number of pairs and then read name value, right? So then, I don't need this, do I? Actually, I need this for comparison later. Okay, and I don't need these two alternatives because it order we're giving the order in the bytes, so that goes there. Deserialization is okay, and then when we unwrap it, we should get equal map for deserialization. Cool. This is just a bonehead way to make a hash map. I guess I could have used that crate that makes it easier, but I didn't feel like it at the time. No seriousness, monads in the practical functional programming sense are just traits with a few functions and simple rules. How functions should behave in combination with each other. Yeah, so I would love to see a practical example of that in a blog somewhere. Especially if it used a language I already know, like Rust or C++. If Rust has generic abstract types, then you could, that's what GAT is, right? Generic abstract type. Then you could sort of implement, what's HKT? That would let you abstract over everything with just combinators. Generic associated types, not as abstract, okay. Higher kinded types. Yeah, so that is over my head. I don't understand what that even means. Mathematically, one can argue option is a monad. I've heard this, but someone saying option is a monad doesn't tell me what a monad is, because option is a monad, but a monad is not necessarily an option, right? Option is the implementation of the maybe monad. Okay. Hierarchy link writes code to C++, then goes to explain what a monad is from that. Okay, that's perfect, Narigara. I'll probably end up giving you more points once I understand it from there. Alright, this is going to fail, right? It's going to go to unimplemented code in deserialized map. Now we need to figure out... So it's going to be like sequence, right? Where I'm going to parse a size and then tell the visitor... Well, let's just get the size part first. We're going to get... It's not length per se, is it? I guess it is. And then we're going to have to tell a visitor to visit something, visit a map. And this map has to be, is a map access thing, so map. It's going to be the similar thing, right? Where it's going to hold on to a length and and our self. So serializer is self and length. So then we'll pull in this thing. It's a different trait that we want, though. Instead of sequence access, it's map access, right? Let's see, what is it? Oh, I pulled in the wrong place. You don't go there. You go there. Okay, so what do we want here? Map access. Map access. Map access. Map. Map. All right. D, not sir. Seer. There we go. I'm waiting for that little bubble. Okay, how come I'm not getting the, This isn't helping. Can I just say implement? Add. It doesn't like to do it. It did it before. So what? I need to pull this out for a second. Oh, I hit the wrong key. I guess I'll pull it all the way out. Just to get, because I'm lazy. There we go. Implement missing members. That's all I wanted. I just wanted to implement missing members. Thank you very much. Now, we can put it back. Right here. There. That's all I wanted. Type error is error. These we can eliminate because we have our own result type that is an alias for that. Okay, key value. I think for key we don't care, right? So I think we just say oh no, we do need the key. Yeah. Okay, so I'm going to cheat and do this. So actually I'll need 2 lengths, won't I? Or maybe we just count it on value. So I won't do that there. We will just deserialize the key, I guess. Don't care about the length. Go back up, go back up, go back up. I want this. When we get to the value, we will, subtract 1. Actually, then I don't even need to subtract 1, do I? We just say length minus equal 1. Like that. Exactly. That was easy. Let's see if it works. Run. Yeah, I mean, it's like I'm in the zone now. I'm just getting it. I'm getting it. Okay, struct. Let's do struct. We're getting to the more advanced elements now. So struct, I had just a foo with a bar and a baz, and I had to, at some point I had to, yeah, I had to tell it to chill about the blacklisted names, because I'm rather fond of these test names. I was actually surprised that Clippy had a problem with blacklisted names in the test configuration. You would think that it would just chill, but yeah, it didn't. So I will probably want all of these. There. Deserialization is the new word. The bytes go first. The structure is what we expect down here. Perfect. Let me catch up with chat a little bit. Rust Analyzer doesn't like struct definitions inside of functions for stuff like autocomplete. It's a bummer. It did it once, but it didn't do it that last time, which is weird. It's about 10% of the time. Clippy not liking foo is annoying. You can customize the invalid names per project. Oh, really? Maybe I just turn them off as a policy for the test module? I do that with non-ASCII literals because I couldn't get this allowed to work anything closer to the source. Defaults to foo, bar, quack. I mean, it makes sense for production code, but for tests, I think that's actually what you want, right? Let's run it. It's actually not complaining about the name this time. It only complains about it some of the time. Okay, deserialize struct. I don't care about the name or fields, right? Don't we just want to tell the visitor to have at it? Visit struct. Visit. There's no visit struct. Visit. How do we visit a structure? Well, thank you for the follow. You could just do allow blacklist a name on top. Yeah, that's what I was thinking about doing it. Yeah, to put it outside. Uh-huh. You know how to build statically linked shared objects. You mean objects like libraries that are statically linked to their dependencies, but yet are shared modules? Sort of like a hybrid library? I know how to do that in C++. I have no idea how to do that in Rust. Yeah, if you're going to statically link, you got to link against the static link versions of your dependencies. Yeah, and if it's on Linux, the system libc is going to be dynamic or shared. But you can override that in most compilers, right? You can say you want the static link version. Okay, I'm right now exploring the visits, but I think I'm going to give up and see how does bincode handle this. Deserialize struct. Oh. Okay, so they just, they degenerate it basically. Is that the right word? It becomes a tuple in the eyes of their deserializer? It makes sense. I don't even think I need a length. Oh. It needs a length. The seed needs a length. Okay, so yeah, okay. That makes sense. Visit tuple. Did I misspell that? Oh, we don't tell the visitor to visit tuple. We tell ourselves to deserialize. Whenever I do this, it's because I'm messing up, but I believe this is correct. It's, yeah, the length first. Yeah, autocomplete is not my friend today. And we don't need the names. We only use the fields to get the length. Wait, is that going to match my serialization? It will because that's compile time length, yes. Alright, so this should work. Yay! It worked. The crate type to static lib will make a static library though. What if you want to make a shared library, but have that shared library link its dependencies statically? It sounds to me like a hybrid. It would be a shared lib, but then the linker option you would give to it would pull in its dependencies as static, which I usually don't. Well, do I do that? I can't remember offhand how you do that. Rust is statically linked for Rust code? Oh, it's not shared? So yeah, if that's the default, then... Oh, so Rust dependencies are always statically linked, but it's the C dependencies that you'd have to be careful about. I just dropped 59 frames. How'd you like that? Next, anyway. I'm getting sidetracked. What's next? Enums. All right, let's do it. Serialize enums. Wait, did I do these out of order? Or was there no enum? Interesting. They're just different. They're in a different order. So what would most closely match enum? I guess just something like a unit variant. That would be the... Well, let's pick a more aggressive one. How about one of these that has a, at least something in it? Yeah, let's just pick this one. So this is an enum where one of the variants has associated data. Deserialize new type variant. Sure, that's fine. So I want all these traits here. So your C runtime and any native deps would need to be configured. Yes. Simply link against Musel. See, I don't know what Musel is, but sure. You can easily dynamically link external Rust code because of generics macros. That makes sense. At least not yet, right? Maybe in some distant future. You can compile your Rust crate to produce a dynamic library. But would that limit you in terms of generics? I have no idea. I'm just curious now. From bytes. And then the bytes have to be swapped with the structure. There. Test. Whole point of the test is to hit the code I haven't implemented yet. Yep, we hit the correct one. All right. So then let me think of how would we do this. I think what we do is decode the variant index and then reach into variants to get the name. But what do we call in the visitor? Visit enum. Okay. The data we need to provide is a what? It says question mark 0.1. I don't... Oh, enum access. Okay. So we need an enum access type at some point. So let's get that ready to go first. Let's see if it can do it in place. Maybe it'll be smart this time. One can only hope. Enum access. Did we get it this time? No. Bummer. So I have to do that other trick now. I have to take this out of this impl block. Just so I can use the code generator here. Hover over that and I get the implement missing members and then I can pull it back in. It's a limitation that I am okay living with for now. Alright, so then that's error. Variant. I don't know what that is yet. But it has something to do with enum, right? So would that variant be v value? My guess would be that it's that. No, it's not. That I can fix like that. Okay, rather than trying to guess what that is, I'll look at bincode again. Deserialize enum. Self. Huh. How is that type used? Self. Oh, that's weird. That's not even a struct, it's an impl. Oh. Okay, they don't even use a wrapper, they just implement it directly. I'll still use a wrapper because this kind of syntax scares me. I'm guessing what this variant means is it's the deserializer to use for the variant. What's this into deserializer do? You can turn an index into a deserializer? How? This is a Serde thing? Huh. I didn't know you could do that. Okay, so anything that can be deserialized, you can make a deserializer from the value. Well, that's wacky. They must implement into deserializer somewhere. No, wait. How does that work for a built-in type? Like, let's say byte or something. Look at the source for that. It's in the macro. I don't know what that is. I should just look at the whole trait, because it's the first time I've noticed this. Converts an existing value into a deserializer from which other values can be deserialized. I don't get that. How does that even work? Like, how does it know? How does this slice know what type to make? I don't understand it at all. I don't get it. Can I learn more online, maybe? I wish they would give me more than to go on than that. Into deserializer. Let's Bing search it. Into deserializer. What is into deserializer? I'm not going to get much help with this, is it? Am I? It's just going to say it does that magically. Should I just go with the magic? It just works? Oh, you can turn anything into a deserializer. I'm confused about how a value like a slice, a string slice, would know how to make a deserializer for itself. Okay, but I'm implementing a deserializer, right? So what kind of deserializer does it make? You looked at the plus show declaration, you have its associated type. Oh, is that what I'm missing? I'm missing the associated type. Okay, so I have to provide the, what is this? Unit deserializer? What is? Oh. Each one has its own thing. So like, let's, for example, look at slice deserializer. I don't really get it. Oh, okay. Okay, that gives me a hint. So it's something that's already deserialized. So it's like a mock deserializer. So when you ask it to deserialize, it just gives you what it's holding. Is that what it's doing? So it's not really deserializing anything. It's just something that, hey, um, you know, when you're asked to deserialize a string, just give it that value that you already have. It implements yeah, but the way it implements deserializer is when it's asked to deserialize, it just calls visit string, right? Yeah. Yeah, deserialize any. Give me something. Okay, here's your string. Yeah, yeah, okay. Interesting that they have to implement enum. Oh, forward to deserializer any. There we go. Okay. So that makes sense. So it just is a string. When you're asked to deserialize, give a string. Okay, now I understand. Yeah, it has for all of its deserialized messages, it just says visit as a string for a string. Okay, I get it. I get it. So it's just wrapping an already deserialized value. Okay, now the way they're using it here is they get the which enum it is. That's a U32. Okay. I think I see where this is going. This is really like turned inside out though, isn't it? Hey there, El Risfriato de la Grieta. I'm looking at really hard to comprehend code here. How to deserialize an enumerated type. The magic is that like you figure out which variant of the enum you get, and then this magic code here somehow turns it into the value with the correct variant. I'm guessing the way it works is that you have to have an enum that's where you've implemented the deserializer. So if we make an enum and we implement deserializer, then Serde implements the reconstructing the enum from the index. That must be how they're doing this, right? So then I would just do the same thing. So the seed taking the index and saying, make a serializer that gives you the index. Okay, I think I get it. The enum expects to deserialize its own index. Look, the Serde, and it was mega magic for, yeah, I'm decoding the magic, no pun intended. Let me show you what I figured out so far from the, the top level. I'm trying to pronounce it as Serde because it's serialization, deserialization. So it's the Rust framework for encoding data structures. Say you're starting with a data structure and you want to send it over a file or WebSocket, whatever. So you want some kind of encoding so that on the other side you can recover the data structure. You go through this framework, and the framework consists of 4 general concepts: serialize, serializer, deserializer, and deserialize. Serialize and deserialize are semantics attached to the data structure to say how to basically decompose the data structure into its elemental parts, like the integers, the strings, and whatnot that are composed into the structure. So it's kind of like chewing up your food, and then now you have partially digested data. The serializer takes that like abstract data model, like the sequence of elements and whatever, and turns it into the actual encoding, whether it's text, JSON, byte string. I'm doing byte string today. And then you send that over the wire or store it in a file or whatnot, and then the rest of it's in reverse. So the deserializer takes that byte string or JSON and turns it into the data model, this abstracted or broken, decomposed version of the structure. and then the structure itself says how to make recompose this, how to reconstruct the structure based off of that data model. So that's from a 10,000 point view, so to speak, of what Serde does. And then specifically what an encoding is, it can be anything you want. It's defined by which serializer, deserializer pair you pick. So if you pick the Serde JSON, you'll get JSON. If you pick bincode, you'll get a byte string. But it's independent from the data structure, which is the important part. When you make a data structure, you only have to define how to serialize and deserialize it, or you can use the auto-generated code. You don't have to worry about how it will look in JSON, byte string, or whatnot. That's the job of the serializer. And the data model is the API between the serializer and the data structure. And this isn't exactly true, but it's sort of like conceptually, my understanding of it is it's the intermediate form of the data structure in a form that's digestible by a serializer, a deserializer. Roughly, it's the elemental types which went into making the data structure, but kind of like you've dropped all of the structural aspects of it, and you just get the data in it. Like the let's pull back the example I had up here before. It was under the overview, right? So this structure where you have a point and you have two integers and they have meaning, you can think of a couple different data models for this. One is just integer. Another one would be a 64-bit integer where the high order bits are the x and the low order bits are y, or the other way around. Another possible data model for this point could be an index into a table of points. So any of those, like two integers, one integer index, there's something that JSON serializer would say, I know how to turn that into JSON, even if I don't understand what its structural significance is, right? It's if you give me two integers, I'll give you two integers. If you give me a map with keys and values, I'll turn that into that, right? So there you go. There's an example. So that's what what I've been playing with today. And right now I'm trying to grok this. This is how to turn an enumerated type. My example here is this new type variant, which has one. I shouldn't say variant here. That's sort of misleading, right? I don't know what to put here, foo or whatever. The name's not important, but you have two variants, A and B. If it's B, there's associated data, right? So one possible encoding of that is if it's an A, you write a 0. If it's a B, you write a 1, followed by the encoding of the data attached to it. So a 1 followed by a 42 would be a B42. A 0 by itself would be an A, right? Hey there, Windy Twitch. And Infinite Star Code, hello to you as well. +1 to Musean, or Musin. Another view of Serialize is just a bunch of visitor implementations on your types which give you a serializer to walk. Sure. I have some light intruding on my blue screen. Let me go shut the blinds. I'll be right back. All right, blinds shut. Okay. Oh, yeah, I was in the middle of actually writing that, wasn't I? Okay, so the idea here was that I was going to decode the which variant it was, and then we don't have a length in here. It's index or variant. Use size, and then so let variant equal self dot parse use size question mark because it might fail, And then given that, we're going to tell it to visit it as an enum. And we're going to make an enum with our serializer self and the variant. And then the type of variant is, that would be this one, right? Can I can't do that, I guess. Oh, I need variant access. Ooh. I didn't notice that. So they implement variant access for their deserializer? They do. Okay. Interesting. So, yeah, those looks like they're pretty simple though. Okay. Let's add that. Yeah, Rust is mostly about compile time deduction of types. There's no reflection. Yeah. Should I implement that trait? Well, let's have a dummy implementation. So it's implementation Serde variant access for reference of lifetime a mute deserializer, which lives as long as a deserializer. Okay. And then implement missing members. Type error is error. So all these results we use a type alias for. The auto-generated, the code generator doesn't realize that, so I have to actually undo that part. Okay. What does it not like about this? Explicit elided lifetime not allowed here. Oh, do I have to say D there? Okay, cool. All right. So I can actually just use debug-driven development to see what we need to implement next, right? We'll get into variant seed. I imagine what we're just going to call it, right? Except for I'm sort of out of my league here. I'm going to cheat again. Deserialize. I'm looking for deserialize enum. There we go. Right. So they deserialize and they turn the index into the proper serializer. So I want to do the same thing. Deserialize and then turn self.variant into deserializer, right? And that gives me a result. Wait a minute, what is this bizarre thing? Oh, we need to couple it with that, which is that. Okay, so then I need to say, okay, early return, comma, self.d. And this is a tuple, so I need extra parentheses. No method named into deserializer found for the type usize in the current scope. Oh, do I need to turn that into like a... Oh no, I need to have a use for that. Okay, that'll work. What if I don't want to do it with the use? Then I can do it the other way, right? Which I can do it with the... Let's do some practice with reverse turbofish. It would be usize as Serde d into deserializer : right? Don't I have to, do I have to do that? No, I put this in the wrong place. That would go, there? No. This little syntax point is, I'm still learning it. I completely lost track of chat. What does the tick do? That's a lifetime in Rust, which is a huge topic unto itself, and I'm nowhere near prepared to teach it to anybody since I barely understand it myself. Really roughly what it is you need these ticks where you have references, and it limits the scope of how long the borrow checker assumes that this reference will last. So if you try to hold on to this reference in something that has a different lifetime than A, it's going to tell you that that reference won't live long enough. And that's as much as I can explain about it. That syntax T as trait method, yeah, that's what I was trying to get to. The T as the trait, and then but the problem is oh, there's the method. So the method is, do I put it there then? This isn't quite right. It's that there's stuff in front of it. Oh, do I put that there? And do that? No, that's not right either. Yeah, I know the other way to do it. It's just I can say this and then into Deserializer, and then I can put self.variant. I know I can do that. I was trying to do the cool turbofish way of doing it though. You're missing the trait import? You don't need the trait import for the turbofish or the this way of doing it. How do you do it with the turbofish variant? The closest I could come to was I need to give the concrete type here, like usize as, or do I just put the value there? It seems to me like the type needs to go there, and then you have this, and then you say into, or do I put the usize there? And maybe I need to put it in parentheses or something. And then dot into Deserializer. It's really close, but it's not quite right. Oh, I can't put the type there? Well, okay, so you're saying I have to put this inside of there? Okay. So that's the nifty turbofish alternative to that. Although it's not much of an alternative, is it? I thought there was a way to basically to turn to do this is essentially what I want to do, like to make it so that this becomes the trait object, and then I can just call it like a method. Maybe I'm just not remembering. Anyway, let's just use the one without the cool turbofish, because I'm not quite good at it yet. So this is the same thing, only without the turbofish, right? It's basically going directly to the trait and then passing in that as the self, or the self-reference or whatnot. Whatever. Does this take self, or does it take self-reference? I don't even remember. I can't even control-click it to find out. Let's find it again. This one. It takes a self-owned. Okay. Anyway, we parse the variant number, and then we tell it to visit an enum, and there's our visitor, or our access that the visitor is given. The visitor calls variant seed, and we'll take the variant which we've already parsed and basically rewrap it as a serializer and tell the seed to deserialize it, and then It'll get back the variant number and then know what to do with it, I think. And I don't need the name or the variance lists. Hopefully this just works. Otherwise, I'm going to be sad. I'm sad. Oh, we're missing an implementation. Okay. Oh, this stuff, right. So for variant access. I need to look at what variant access means, since I haven't seen this type before. It's a visitor that's created by the deserializer and passed to the deserializer to deserialize the content of a particular enum variant. All right. The example data format presented on this website demonstrates the implementation of variant access for basic JSON data. Okay. Oh, so I need to have a unit test for each of these, and the one I chose to do was a new type one, right? Yeah, and then for a new type, we just need to forward it, right? So it would be c.deserialize self, and that should work. All right, cool. So then I know what to do. I'm back in parity with the serializer, right? Because we have other types of variants. We have here's the unit variant. Let's pull that one in. Deserialize unit variant. So derive the deserialize, debug, and all that good stuff. Partial equal. And this is from bytes. Deserialization instead of that. Okay. Oh, I need to reverse value and expected. Now the value is the byte stream in, the expected is the variant variant out, the enum value out. Okay, so this should hit the other unimplemented one, right? Yeah, the unit variant, and for that I do nothing. I just say okay, because we don't need to do any work because there's no attached data. So that should pass now. Cool. Okay. I have a basic understanding of it, enough to get by. I need to do the enum with the structure in it, right? Let's just look at the to-dos. Okay, I need a tuple variant and a struct variant. Okay, I think I have unit tests for those. Yeah, here we go, tuple variant and the struct variant. Which one do I want to do first? Let's keep them in the order in which they're marked to do. So this one's next, right? The tuple variant. Deserialize. Hello, Saru. Sometimes you have multiple implementations. Maybe it goes type, which is what the turbofish, forward turbofish is for. Okay. I'm not a master of the forward turbofish yet. Oh, but I see what you're saying. Like in the forward turbofish, you actually put the concrete type all the way on the left side, whereas the way I did it, I don't actually have the concrete type mentioned anywhere, right? Yeah, this doesn't mention that the concrete type is usize. You just have to infer it from the value, right? But if this implemented this trait, this function through multiple traits, actually, well, doesn't it? How can it still be ambiguous? I'm trying to think of a scenario in which we did like the turbofish variant of this, right? Which is usize. Well, that as this, right? Oops, I put that in the wrong place. So there's a forward turbofish version, right? How come I have a question mark there now? Did I mess this up? Let me undo for a little bit. Wait. How come with that it can't convert the error to error? Is it because it needs to know the type there? No, there's something else different. Did I not do that right? Oh, I see what you're saying, Musin. If this was a variant, like T, then we won't know the concrete type unless we specify it right there, right? But still, I'm confused now. Why does this now have trouble with the try? Because I thought that was essentially the same as doing that. Am I wrong? Okay, that's maybe something I'll look at later. Confused. I'm confused. The integer serializer has an associated type, so is it that it's unclear what the associated type was? Oh, so since it doesn't know the associated type, it can't run it through the try. So, okay. That's really hard for me to think about right now for some reason. I'm having a hard time visualizing that, really. Okay. This stuff gets easier the more you practice with it. This, it just doesn't know the type, right? No, it's saying that I didn't implement the correct traits. Now it can compare them and debug if they don't match. Okay, so here I should hit the unimplemented function. There. Tuple variant. I just want to handle it like a tuple, don't I? Let me think about this. Yeah, don't I just want to call self.d... Wait, I can't call self. Wait, why can't I call deserialize tuple length visitor? Why can I not? I have to actually use a really? Okay, why? Oh, because it's in a different trait and I didn't put a use in there for it. Okay, so then I can do like self as this deserialized tuple, right? I have to say self here. That'll work. There's a weird quirk is that if you have a trait bound, then it implicitly imports that trait. Yeah, like that's why I didn't have to do this earlier. Yeah. Right? Because I was doing that all the time here, and I could get away with it because it, so this becomes like as if we did a use on it, right? Yeah, that's what confused me. Definitely that confused me. I'm like, I didn't have to do that before. Why do I have to do that now, right? It's because we're in a different one. So that is now effectively used, but not the other one. Okay, let's see if I guessed correctly. I am sort of guessing here. Yeah, I guessed correctly. All right. Next, tuple struct, right? So tuple struct is like a 3D coordinates, right? Deserialize one of these. Actually, this is simpler than that. I should have probably done this one first. Then it was just defined in the reverse order. All right. So if the data is 2, 4, 6, then we should get back a chords 2, 4, 6. Why do we have an error here? Oh, I already did that one? Wait, where? There, I already did it. Okay, then was looking at the wrong to-do then? Go back up there. Oh, okay, wrong one. Struct variant is what I want. Where is that one? So it'll be an enum with a struct inside. I'm looking. Oh, here it is. This one triggered the blacklisted name warning last night when I did the serialized version of it. Let's see if I need to do this again. So this is an enum where one of the variants actually has a structure for its associated data. All right, so then that goes there. The data goes here. The variant, the enum with the variant and the structure goes there. All right, now we should hit the to-do. And it didn't have a warning about the bar and baz, so I'm going to remove that. Okay, cool. Hit the to-do. So I think I want exactly the same thing, don't I? That it is not a tuple, but it would just be deserialized, wouldn't it? No, I need to tell it what to deserialize it as. Struct, right? No, this isn't right. Let me think about this. Wouldn't I just tell the visitor to visit the struct? Well, there was no visit struct. Okay, how did we do parse or deserialize struct then? Oh, we told it as a tuple. Okay. All right. So it's the same thing. Only, okay, the length here is the number of fields. Yeah, all right. Let's do it. I have a good feeling about this one. Yay. Cool. Hey there, Turn Forever. I'm almost through with this custom serialization stuff, and then I'll be able to like clean it up and then call it a day. At least as far as this library is concerned. I'll probably keep streaming. Tuples are structured with numeric fields instead of name fields. Yeah, that makes sense, especially if you compare this is a structure versus this one as a tuple. This one has 2 integers and this one has 2. It's just that these ones don't have names. They have indices, I guess you could say. Like .0 and .1. So it makes sense that we implement them the same way, right? That if it's a variant, if it's a tuple variant, then we it's just like a tuple. But if it's a struct, then it's also a tuple, but then we have to count the number of fields to see what the length is. Yeah, okay. I'm not explaining that very well, but that's okay. Okay, I have some other to-dos here. Deserialize identifier, ignored any. I don't... Okay, is those the only to-dos left? Yep. I actually don't know when that's called. Your format keeps the fields and you can't do it like this. Mine does not, though. Mine will basically count on the fact that the structure doesn't have different fields, or like once I serialize a structure, or when we deserialize it, the fields should be the same fields in the same order. Otherwise, it's all going to break down. If I wanted to be more flexible, I'd have to encode the field names, right? And then we have to check to see if the encoding has names that we don't recognize, and then we would, I guess, generate an error or something, or just drop them. Yeah, exactly. For an encoding where you like a JSON object, do you need to keep the names as the keys in the JSON? True. For mine though, I don't care. I'm dropping them because the I'm gonna end up in the serialize and deserialize. I'm gonna end up versioning those anyway as a solution for that. Just the classic way to do a version evolving serialization. Or I have to avoid using that word because it means something else here. A version aware format. Okay, so where is that used? Deserialize identifier. Let's see. Hint that the deserialized type is expecting the name of a struct field or the discriminant of an enum variant. I think we're going to throw an error here because we're going to say our encoding doesn't provide structure fields or enum variant discriminants. Right? Let's see what the bincode does. Deserialize identifier. Yeah, they don't support it. And while we're here, what do they do for the other one? Ignored any. Yeah, they just don't support it. I think we're going to do the same thing. Yeah. Needs to deserialize a value whose type doesn't matter because it's ignored. I'm just trying to think, where would this be used? So in some kind of format where you have a value that you don't end up caring about when you deserialize, like maybe a comment or something? I guess, yeah, we're just going to say we don't support it. So, error. So technically we don't support it because of what reason? Identifier unknown. We don't know the identifier. Yeah, identifier unknown. That we'd like to give them the name, but we don't know what it is because it's not in the encoding. And this would be like type unknown, I guess. Yeah, we can't deserialize it without knowing the type. Can't deserialize without knowing the type, right? So this other one I need to invent is identifier unknown. Cannot determine identifiers in this encoding, in this format. There we go. Yeah, I know we could use the message custom, but their documentation also said you can have your own values, and then we're just leveraging this error because it's going to turn this into a reason anyway. So either way, it's fine, right? Yeah, I'm using my own error type with this, leveraging this error. I'm a fan of this error and anyhow now. I love them. I'm glad that you and others suggested I learn it. Okay, so that means we don't need the visitor at all. Now we're out of warnings. Time for me to run all the unit tests and check it in. Okay, close all of the terminals but one. Run cargo test. 58 passed tests. That's what I want to see. Cargo, or not cargo, get cola. That's right, anyhow, and this error made by the same people. Oh, same person also in Serde? That's cool. I think I knew that, but I forgot. So we're going to say finish implementation of Deserializer. All right. Half the highly useful crates are made by D. Tolnay. Yeah, I've seen that name all over the place. I haven't seen Burnt Sushi's crates, though. Yeah. And there are also some super useful crates made by people you might recognize. Like Musean. The Twitch API crate, right? Or what was it? The feature lister or dependency chain lister. I forget which one that was. Burnt Sushi's regex CSV term color. Okay, yeah, those are crates I haven't looked at yet. That would make sense why I haven't seen his name. Okay, do I want to do any cleanup of this, or do I just move on? Do I have any to-dos marked in the code? Oh, I can do this now. Yeah. So, warn about missing docs. Remove error about missing docs. Okay. So yeah, I'm gonna need the crate level documentation. This crate provides a Serde Serializer Deserializer. He uses modules to fake items to attach all that meta documentation to. Huh. They have the best documentation. They even include guides and cookbooks. Nice. After this, you fought for like an hour to get symbols you wanted exported correctly. Oh, what you wanted to do was set the crate type to cdilib. Oh. Okay. That's saying to import the C libraries as dynamic libraries, right? So there you go. You know, that's fine. Don't feel bad that it takes an hour to figure out that it's just one setting you need. Right. That sounds like it, right? Use Rust as an FFI. Okay, this crate provides a Serializer Deserializer implementation similar to bincode. And yeah, matching the encoding which is used. I don't want to go first person here, but it's like matching the encoding which is used in my game, right? So what do I want to say? Maybe just keep it like that. This crate provides a serializer implementation similar to bincode. Maybe keep it simple. And let's reference Serde. I prefer to reference their crates IO, I think. Let's go to crates IO. Actually, what's better to reference? Crates IO or probably their documentation would be better to reference, right? So go to the top of this, right? Interesting that they aren't on docs.rs. They have docserde.rs. I haven't seen that before. Oh wait, they do have a docs.rs. Let's link that one. That one's better, right? That's shorter. Bincode. Copy link address. There we go. I don't know. Do I really need to say much? What do bincode say in their API reference? Okay, they have an example. I never did the 128-bit stuff. Yeah, I guess I'll have a similar example. Examples. And rather than come up with this from scratch, let me go to a different crate like Pantry or something that has a top-level example with right here. Yeah. Just grab this as a template. Okay, I'm going to need to turn all these into doc level comments. All right. So I don't need these two, but I do need this one. That's a placeholder name. I need to make my own name. We end up wanting to use serialization, right? Serializer. Okay, I forget why I did it this way in this example. Was this not intended to be run? Yeah, okay, that's not the best template because it doesn't have a main in it. Let me not look at that, but maybe the WebSocket one. No, WebSocket one, no, right? How about the HTTP one? That would be a better one. Source, maybe request. Here we go. This one's got a main that returns an error, so yeah, I like this one better. Let's grab that. For this part. And I have to fix all these up again. Not a problem, we can do this. Alright, so then, should I hide the error here? Yeah. I'll hide the fact that we're also using our error type. Just for readability, right? So, actually, I don't need to do that, right? This line's already hidden, so I can just do that. Okay, so then how do we use this serialization? We would just say let greeting equal hello world, and then let encoded message equal greeting dot serialize. No, serializer 2 bytes greeting. Right? And then let decoded message. I guess that means we're going to pull in the deserializer. From bytes. Encoded message. And then assert equal greeting decoded message. That's good, right? Let's run cargo test doc. Is that right? It failed. Oh, did I not export the from bytes? Oh, right. I remember what I did for that. I chose to... I didn't have it part of the class. I guess we can add that. I have 2 bytes, but it's not a member of the class right now. Well, Musin, I saw that bincode does both, and I was thinking about that might be a handy thing to have. So in their is this it? In their lib, they have a serialize function that's top level, just to pull in default options. But then they also have a serialize. Is this it? No. They also have a serialize inside of their type too. Inside of their serializer, I think. Now I can't find it. Oh, here it is. I thought they did. Maybe I saw it from their documentation. Yeah, default configuration, but I thought that they also had one inside their serializer. I could be wrong. Maybe I'm wrong. Maybe they do, but it's internal. Okay, so I'm wrong. Yeah, they have a configuration type too. Okay, so then I mean, there's nothing that says I can't do that, right? What looks better? I guess more people are used to looking at Serde things would assume that I would have like 2 bytes from bytes here instead, right? Yeah, okay, fine. I've convinced myself. Okay, I need to wait, why did it oh right, we need to borrow that when we I love it that it'll test stuff inside of comments. Doesn't have a size known at compile time. It doesn't? Oh, do I need to borrow the greeting? Don't have a semicolon. I got a unit out of that. Did I do that wrong? Why am I getting a unit out of from bytes? The convention and the Serde docs recommend the 6 top level functions. I do have the recommended format here. Okay, I must have done the from bytes wrong. Oh, do I need to be explicit about what type I want? Do I need to say string? There we go. I wonder why it picked unit. Maybe it would have picked the right thing if I had done that. Oh, that's weird. So it already is a slice. Yeah, why does this need a type inference? Anyway, I should just do that, right? Well, we don't need to allocate memory. The dog might be barking. The dog was giving me warning little. Someone might be coming home from school yet. Do you have a sized bound? Probably not. Is that what might cause something like that to happen? That would be in their lib, right? Yeah, they do. I don't think I... No, that's in the trait. Where is their deserializer? That's here. No. Actually, that is the correct place. No, it's not. I need to go to bincode. This one. I thought they had constraints on sized. No, maybe not. The top type in Rust, what all types are classified under as unit. In my from bytes. Okay, yeah, I did not. I don't have a sized constraint, but neither did they. Deserialize. Yeah, they don't have they don't seem to have a sized constraint either. So I would say plus sized. Do I need that though? I guess it makes sense. Oh wait, yeah, you're right. This already is size, so I don't need to say that, do I? So then, yeah, that's kind of weird, don't you think? That they, I need to say that, otherwise it assumes unit, even though I have an equal. You'd think that it would just figure out what the type needs to be to make them comparable. Weird. Well, you know, I don't mind saying that. Hey, Cindy. How are you today? Is that the problem? Well, it says it's not... It picked a type that it's not comparable, though. Yeah, but you're right. I could have made it string, too, right? I could have made it a lot of different things. Well, we'll just go with this one. If I run test, it runs doc test too, right? It'll pick unit because it's the top type. I haven't run into that before, though. But I would think that it would pick one that would allow it to compile. That it would deduce the type of decoded message. Like, isn't that what I've been doing in my tests a lot of the time? Yeah, like this, for example. I didn't have to give a type here. Oh, wait. I just thought of something. Is it because I have the early return there? And the return is unit. Maybe that's the problem. So if I were to say that it returns a slice or something, well, can't return a slice though, but I could not have an early return here and just say assert decoded message is okay. That's what I do in my unit test anyway. Let decoded message equal decoded. I'm not going to actually leave it like this because it looks horrible, but I want to see if that makes it actually work. Now it says that type annotation is needed. I guess that makes sense because you're saying that there are a lot of things you can compare a slice to, right? Okay, yeah. That makes sense to me that it has to do with unwrap can only be used for a few types, so it has nothing to do with that, right? Just out of curiosity, if I were to do that and then make that a string and then have it okay decoded message, would it figure it out? Invalid return type. Oh, you can't return a result? Okay. Well, what if I made it, I don't know, not main? Yeah, okay, so that works because it figures out what the type should be from the fact that we were returning it, right? All right, and then since it's not used, okay, I think I get it. So we'll just leave it as slice for now. Yeah, okay. That's fine. Now to compare with what did they do in their top level. And by they, I mean bincode. Okay, so they also actually did it on both. Maybe that would make sense for me too. So it's more clear that that is a vector of bytes because that's what we get out. Yeah. They included unwrap. How could they? We're supposed to avoid doing that in documentation, right? This is the better way, right? Is to say that it's fallible. They also made it more complicated by having an option. So I'm keeping mine simpler by having it not be an option. All right. You should unwrap in doc tests? What? I was told by someone else in chat that it's better to use question mark in documentation and to hide the fact that we're returning an error. Okay, Musin, you're giving me conflicting advice from someone else, so I don't know who to trust. Someone else, I can't even remember who it was, told me, and they convinced me that it's nicer to use the try operator because it's a hint that it's fallible and it'll return some kind of error. But you're saying no. Makes it way harder to figure out. Well, I probably should give you the benefit of the doubt until I hear from someone else, because I can't remember who told me in the first place. So I guess we will unwrap it, or should I just reveal the function main? No, let's not do that. Okay, I'll just do unwrap, and then I don't need to have the. I don't actually need this at all, do I? Well, it'll put it in a function by itself, right? If I do that. Let me mess it up a little bit. Let's make it fail at runtime. Cool. So I wanted to make sure it actually ran it. So now that I know it runs it, I can put it back to that. And now we'll know that it actually gets run as well as compiled. Okay. So I'll go with you since I trust you better. Why not use unwrap and remove? Yeah, it'll speed up compilation, makes the doc simpler. I was just convinced by someone that to avoid using unwrap in documentation. We still want to avoid using unwrap in production code, though, right? Because it's better to have actual error handling. Yeah, okay. You convinced me to go back the other way. That means that I should probably go back to my other crates and fix them there, too. To do, go back through previous crates and use unwrap instead of question mark in doc examples. In documentation itself, you should show idiomatic usage. You're talking about in documentation tests. Well, this is an example at the crate level documentation about how to use it. So that's not how one should generally use it, right? Yeah, I don't actually care about errors there. This will always encode and it will always decode. Well, the fact that they do exactly that gives me some more confidence. In fact, they show an FN main. Why do they show the FN main then? I wonder. Makes me wonder, you know? Anyway, let's continue. So, top level, we're good now. Error, I need to document all my errors, right? These are the various... Ooh, Silmeth just wrote a long one. After some time reading and head scratching, you can't see how option with return unit being option sum, join being option flatten, and bind being option and then does not follow monad laws and is not a monad. And what it has to do with being able to replace sum with bar, except that there is no language level generic construct for a monad. Strictly option is just a monadic type. You said too many monads for me to understand that completely, because I don't understand a monad yet. Sorry for turning it, just wonder what you meant by if not following the monad laws. Okay. That's true. Rust doesn't have type constructors. You have to add it as an add-on convention, right? The new is like a de facto standard constructor. There are these are the various. What? How do I usually document errors? Let's go back to I don't know server source lib. Oh, I haven't even published that yet, so scratch that one. How about WebSocket? No, I haven't published that one either. Which one did I publish? Type constructors refer to type parameters here. Oh, different type of compiler? I was thinking about instance constructor. So what's a type constructor then? How you make a type from another type. I don't get what that means. Do I have errors in pantry? I don't think no, I do. Where did I document the errors? No, pantry doesn't have its own errors. It didn't need them. So by pantry, what had errors? HTTP had errors. I'm gonna look there. There we go. This is the enumeration. Actually, I like that because that's enough said, right? This is the enumeration of all the different kinds of errors which this crate generates. So this is a more wordy explanation of what's going on. This is the well, the convention. Is convention or convention? Convention, right? I can't remember. I can't spell. Define convention. And now define convention. Okay, so it corrected my spelling, so I guess it is T. There's a neat this error alternative. I kind of like this error. It does what I need it to do. Composing compile time types, e.g. in vector T, the type constructor is the less than greater than the turn a vector into say a vector T. Oh, okay. So it's like type composition. The syntax for composing types. See ya, Dr. Padawan. Thanks for being here. Okay, I guess I understand that. So it's just making a type out of other types. And type recipes. Conversion, conversation. No, we want convention. The convention, the Serde convention is to what? Is to provide a catch-all error variant to hold any kind of error message, which a which the data structure may emit during serialization. This variant serves that need. This is really poorly written, isn't it? You don't need to write the documentation plus the attribute. It's all the same thing. Yeah, this concept of higher kinded types is something I don't get either. This is returned if the input buffer is fully consumed before the complete data struct. Okay, dog barking. Sorry about that. Someone's coming home, the dog is greeting them. This is returned to the input data is not fully consumed before the data is fully deserialized. Okay. This serializer does not support deserializing sequences of lengths not known at compile time or I would say unbounded sequences. This is returned if I'm gonna just leave it at that. This serializer does not support deserializing values of unknown types. Okay. An integer overflow or underflow occurred while deserializing. I would say an overflow or underflow occurred while deserializing an integer. All right. Invalid, well, an invalid byte sequence was encountered while deserializing UTF-8 encoded text. Hey there, fluffy squirrels. I just finished what the today command is talking about. Custom serialization code in Rust. Just finished it, and I am finishing up the documentation for it. And what about, what is serialization, deserialization? I have a little page for that. So it's Serde, stands for serialization, deserialization. It's actually a crate in Rust, but it's also a de facto standard. It's the framework in Rust for encoding data structures. So given some kind of data structure, if you need to encode it into say like JSON or a text or a byte string, like maybe you're going to save it in a file or send it across a network connection, you would use this framework. And it's a two-step to go from either data structure to an encoding or back to a data structure. And I implemented the second step, or the internal step here, the one that goes between an encoding of data and a data model. And the outer one, the serialize and deserialize, usually is tied to the actual data structure. And I need to do that for my game's data structures later, but yeah, today it was just focusing on the internal part of that. And when we talk about data model in this diagram, it's the intermediate form of the data where we've broken the structure up into its elemental types. So integers, strings, tuples, that kind of thing. That's what we're doing today. So I have a library now for Rust that does basically, like I say at the top, it's similar to the bincode crate, which you can look up here, but it's my own version of that. So I essentially made my own version of the bincode crate, because I like to reinvent the wheel here. But Rust isn't a functional language, definitely not a purely functional language. It's not a functional language? That, oh, purely functional language. Yeah, yeah, yeah. Of course, you can do things in procedurally in Rust too if you really want to. Yeah, reinventing the wheels are fun. I learned a ton about how Serde works internally. I know about visitors somewhat. All right. This serializer does not include identifiers in its format, and so cannot determine them during deserialization. Okay, one more. Missing documentation for type alias. Okay, there we go. This type alias provides a convenient wrapper for the Rust standard result type when the error associated type. It's not the associated type, it's the type argument, right? We're talking about type construction. The error type argument is our own error type. I think I can just refer that back to the same page, right? I think we still need to say struct.error.html. All right, so we're done with error. Let's look at serialization. So the only thing I need to document is the 2 bytes and then the serializer itself, right? Does that not even need to be public? Do I even need to make that public? Hold on. Why would that be required, actually? Conventions. Why did they publicly expose the serializer? I don't see, they don't explain why would we expose this serializer deserializer? Might be required for the derive macros. Okay. Good point, fluffy squirrels. Okay, so I guess we'll stick to that convention. So really they can't use it anyway because none of the like the new and my serialized helper here are not public anyway. All right, anyway, I guess we'll just say this type implements Serde serializer. And in order to encode data into a sequence of bytes. Chat is exploding. We're talking about all sorts of things. Monads, lifetimes. I'm having a hard time keeping up with chat. Mostly the words that you guys are using, I haven't quite learned, like, I don't know what affine typing means, so. Yeah, you've gone beyond my level of skill and understanding. All right. It's a great discussion. I wish I could be a part of it, though. In order to... Okay, so I should probably link directly to their documentation for that, right? So... Yeah, I don't have a window open to Serde's documentation, so let's get one open. Serde. Hey there, Pyrofrosty. How you doing? I'm just wrapping up a new library I made to do data formatting. And doing some documentation writing a little bit now. So what was it? It took me about 3.5 hours to do one half of the library. Well, more like a third of the library. And it has to do with this stuff. Framework for turning data into byte streams and stuff like that. So I want to reference their serializer type, right? So I want... Actually, this is going to reference it by version number. Can I reference it generically? Can I, like, reference the... I guess it's okay. So we'll end up referencing their documentation by explicit version number. Is there a way to, like, say latest? What if I say latest there? Is it going to totally break? Latest. Oh, that actually works? Oh, sweet. That actually works. That's what I want. Okay, so... Yeah, it's going to wrap it like that. Okay. And then I need to wrap to... this is the very top level function you do to encode. This function is used to encode a value into a string, into a sequence of bytes using the serializer implemented by this crate. You can also use star for the version. So what would be cool is if I could actually use 1.0 actually, because that's what I really depend on, right? Then if they make a 2.0, like, if that works, that would be even better. Let's see if that works. Oh, it works! Because that's exactly what my dependency is in Cargo Toml, right? 1.0. Oh, we're not dependent on bincode anymore, by the way. That's exactly what I want. You know, the only way to make this better would be if I said docs serde look for version in my cargo.toml. I'm pretty sure there's no way to do that, though. It'll be 1.0 for the foreseeable future. Well, that's until they make a 1.1 or a 2.0. Serde 2.0, and then all my links will be broken. It makes me a little uncomfortable actually to have references like that, because then I have to remember that if I ever were to pick a different number here, that it'll break my documentation unless I remember to go here and change it there as well. It would be cool if I could have it just in one place and then updates the documentation automatically. This function is used to encode a value into a sequence of bytes using the serializer implemented by this crate. And we have to say what errors it returns, right? As with any Serde serializer, this function is fallible. We should say what it returns, though. Oh, there's another huge Silmouth comment. I just can't grok that. I don't know monads yet. I really wish I could go learn monads and then come back and reread your discussion. Okay, as with any Serde serializer, this function may return an error if the... well, really it shouldn't return any error. But really, I read about this last night. It may return an error if the value being serialized is in a bad state. Such as, for example, if it contains a mutex which is locked by a thread which has panicked. True statement. I remember reading that last night. I'm like, whoa, that's pretty deep. So if you take a structure and try to serialize it, and that structure contains a mutex which is locked by a thread which is panicked, you can't serialize it. Or it's possible for it to error out during serialization. Okay, then we're done with serialize, right? What do we need for deserialize? I need all of those to be what? Documented? Wait, why would I need to list it here? This is not public. Oh no, it is public. Shoot, because this is implementation of a public trait. Oh, okay. Well, what do we say for Sir? Seer. We said that. So, deserialize. This implements Deserializer in order to decode data from a sequence of bytes. Good night, Silmith. You didn't derail the chat. It was mostly you went on a parallel track that I couldn't follow because I don't understand enough of it. But you were discussing it with at least 3 other people who understood what they're talking about, so it's fine. You should have a serializer with capacity as well. Oh, so I don't have to, so I don't need to constantly reallocate memory as we go? Yeah, that I thought about that last night when I was looking at bincode, and they talk about that they support both going to a vector as well as reader-writer API. So I don't do that yet. I think I will add that to my list. So consider adding reader-writer support in the serialization crate, as well as a way to serialize with capacity. So that basically we don't have to, because normally what this does is it just, the serialize will make a new vector, and it will just allocate more and more memory as we go. But if we knew roughly how big the serialized message would be, we could just allocate the memory once. Vec already implements standard IO write, so they can pre-allocate their vector and pass it to my impl write. Yeah. So you're saying if I implemented the reader writer, then I wouldn't need this so much because you could just use the writer with a vector, and they would do it for me. How would they know how much memory to allocate, though? Oh, one would use the writer's pre-allocate function, right? I get it. So I wouldn't need to implement it because the vector would do it. Yeah, 640K should be enough. Yeah, good one. I thought it was was it 64 or 640? I guess it was 640. Was that Bill Gates who said that? 640 kilobytes should be enough for anyone. All right, let's go to 2 bytes. This one has more substantial errors that can occur. This function is used to decode a value from a sequence of bytes using the deserializer implemented by this crate. As with any Serde deserializer, this function may return several kinds of errors for reasons such as running out of input bytes while still deserializing the data. encountering corrupted or yeah, encountering corrupted input, I guess. What else? I actually just refer to my error type. Truncated, overflow. Yeah, this would be corrupted data. I guess this would be attempting to use a feature not supported by this deserializer. Such as unbounded sequences, or the other one was like determining an identifier. Let's just keep it simple. There we go. Vec U8 implements write. Slice of bytes implements read. You have this. Okay, so in the future, struct serializer for a writer. The implementation of it would say from writer. I don't know if I need to copy that because I could just refer back to bincode. They probably have that, right? So if I look at bincode's deserializer, they probably have a writer, reader in this case, right? I'm looking for it. Would it be this IO reader and slice reader? Maybe. Oh, let me copy your note. Thank you, Musen. Okay. It kind of sucks that I have to go and actually document these functions. Can I just take the easy way out and say that to suppress missing errors doc from just this trait? Because no one's going to look at my implementation and expect me to have documented that. Yeah, what if I just do this? Allow missing errors doc for just this implementation block. Now we're down to no errors, right? Let me run the doc. Cargo doc open. And see what it looks like. See if I feel like adding more to it. While it does that, I'm going to take a drink. All right. What time is it? 3:20? Yeah, I can keep going if I feel like it. Let's see. Script provides a Serde that link work. Yep. Bincode link work. Yep. That's fine, right? Oh, that didn't work. Broken link. Alert. Broken link. That was in the deserializer. I have a broken link at the top. Right. That goes there. Cargo doc. I don't need to open it again since I already have it open. I just do that and reload. Now it's fixed. Make sure that they actually link correctly. They do. Okay, that's fine. Deserializer. Yeah, I mean, I think this, I can just keep it simple, right? Right. Okay. Oh, I have a period at the end, but not there. Yeah, I'm nitpicky about that kind of thing. Would look better not capitalized for bullet points. Or am I just strange? I think it should be capitalized, even though they're not sentences. I need to ask like an English teacher. Are you supposed to, even though that's not a complete sentence, do you put a period at the end or and capitalize it or not? Capitalization looks like it should be there, but I don't know about period because it's not a complete sentence. But you could think of it as if each of these are alternatives to complete that sentence, it should not be capitalized and you should end in a period, right? So I'm confused. I don't know. Cargo doc, no docs dash p, regex p cert open will disable all dependencies except regex and regex. Produce documentation for those two in my project. Oh, you mean so I wouldn't see all this stuff here? I don't really mind too much that all this stuff is extra stuff shows up because when I publish this, it goes to docs.rs and they run the right command for me. So if I go to like my Raimurai, for example, the API reference, it just has my crate and doesn't have any other garbage or, you know, dependencies. So I don't really care if locally it shows a bunch of garbage there. Yeah, and the Serializer, you're right. It would probably go faster, but it's not slow enough that it bothers me yet. So I just, I'm lazy and just do without any arguments because then I don't have to remember any arguments. I think I missed a few people joining while the discussion was going on about monads. I never said hi to fluffy squirrels. Hi. Daniel, I never said hi to. You're one of the people talking about monads. And then Mantis, I missed your comment as well. You said hey, like half an hour ago. I'm sorry that I missed the hey. Hold on. Still finding where it is. There it is. Hey, Mantis, if you're still here. Okay. Done with that. I think let's check it in. I think I want to try to use my own crate now in the raft stuff I was working on before. This is separate, right? So remove bincode dependency used during development. I was mostly using that so I can easily compare theirs to mine. Okay, now this is all documentation, right? So add crate documentation, commit, and I'll publish that later after I use it for a while. Okay, so then let's say we want to use that crate from my Rust crate, right? Here's the Rust crate. I'm going to want to say, we're keeping Serde JSON because I use that internally for some things, right? But we're going to add serialization, which is the temporary name for it. Path serialization. Is that not the right format? Probably not. That doesn't look right. So I'm going to look at what I did here. Not there. Right, WebSockets would have done this. WebSockets. Oh, okay, so it's just an object, not an array. Yeah, I should have realized that. It's an object. I haven't used Toml that much, that's why. Okay, so then, where I was doing this custom serialization junk, right? We're going to remove this because this is, a lot of this is the, like this deserialized string and usize. This is all what my crate is supposed to replace. So I think what I want to do here is just start with the, with deriving Serde directly, and then I'll customize it later. So, we want to pull in Serde again. So that Hey there, Romania Hate. It's going well. I got my own custom serialization library successfully written. It's like bin code, only it's mine. And it's pretty cool. So now I'm going back to my rat implementation where I was dealing with like serialization junk, and I'm gonna try to use it. So was it log entry or log entry have serialization junk in it? Don't think it did. It just had going to JSON and stuff, right? I was going to add serialization here, but I never did. I'll need to come back and do that. So it's message I want to work on first, right? Yeah, I'm already done. It took what? Roughly 4 hours today and like about 4 hours yesterday. And if you want to take a look, I have it checked in. github.com/rymaway354/serialization.git. I don't have a crate name for it, so right now there's a placeholder name. I'll probably name it something unique when I publish it. Wish you had that patience to implement your own libraries. See, Romania Hate, it is a bit redundant for me to implement it because I could have just used bincode. But on the other hand, I ended up learning a ton about Serde in the process of implementing it. And looking at my code compared to bincode, I learned a lot. So I like to justify doing stuff from scratch at least once as a lever for me to learn. It forces me to learn it and to implement it. And the way I handle something big like serialization libraries, I just one step at a time. So I did, let's go back to that. Thank you for the follow. I started with the basic stuff. Let's find it again. Here it is. So it was like serialize a bool or something was the very first test, right? Yeah, serialize a bool. So when you put false in, you should get 0 out. If you put in true, you should get 1 out. And then a lot of the learning was knowing that the way you serialize stuff is you use Serde serialize, and you have to give it a serializer. And this is my serializer. And then that there's a connection then formed. There's Serde's serialize will end up converting the bool into the data model equivalent of a bool, which since it's an elemental thing, it's 1-to-1. And then it's going to end up calling my serialize bool, right? And then it's just knowing that is the learning process. Implementing it was super easy because it's like, okay, if you get a true, then you push 1. Otherwise, you push a 0 and you're done. Super easy, right? And then it gets a little bit harder when you do 8-bit integer. It's like, okay, now instead of 1 or 0, now you have to take that value and push it as a byte. So you basically drop the sign. And then it gets a little bit harder for larger integers. I wanted to do this like almost like a run length, not a run length encoding, but a Huffman encoding style where like it's 1 byte if you can fit it in 7 bits. Otherwise, it's 2 bytes if you can fit it in 14 bits, etc. And so when you look at it, it's a little bit more complicated. But mostly it's because I want to have these bits for like the sign. I want to encode the sign bit. I want to encode this more bit for every byte. And then I get the bytes in reverse order and then I add them with the next bit set. But anyway, actually plugging in and using that function, most of these are one-liners, right? Here's where it got a little bit fun. With a floating point, I couldn't find any way to get the raw bytes of a floating point number without going unsafe. Basically taking the floating point value, getting its address, converting that pointer to a 32-bit integer, and then dereferencing that. And so basically a brutal byte cast from float to integer to get the bytes. F32 has 2 bits and the reverse as well, totally safe, so I didn't have to do this. But this was fun, and this is what bincode does. Maybe bincode had this before, it's older than the 2 bits, maybe? I stole this idea from bincode. That's what they do. They don't do this loop with the shifting. They have a more like from the perspective of is it big endian or little endian, and they do like one or the other. But I'm a fan of pushing bytes in network order that way. You hate floats? They're not too terrible. But yeah, if you look at the detail, it's a lot of it's straightforward. Like structural, the formatting of structures we don't care about, so we just drop them. The only thing that we preserve out of structures and tuples and that kind of thing are the lengths. So we'll encode the lengths and then just handle everything as a generic sequence. Yeah, like a tuple, it's like, okay, we don't need to do anything for a tuple or a tuple struct. Tuple variant, the only thing we care about is the serializing the variant index. Everything else we don't care. We don't need the name, we don't need the length, yada yada. So every individual function was reasonably easy to do, but a lot of the learning was knowing like how do we get to these functions from the outer level, which is this 2 bytes which calls serialize with Serde. Making that connection was the hard part, and then Deserializer was similar. Two bits from bits are 1.20, so pretty old. So why didn't bincode use to bits then? 2 BE bytes now? Yeah. That's okay. I can have a little bit of unsafe in my code, right? It doesn't have to be perfect. Plus I want to move on and do something else right now. Wanted to find the tests that do some encoding. Right, so this stuff. I think what I'll do is I will blow away serialize. Yeah. This stuff, I'm going to blow it away. Because I want to use Serde for this. We'll have to bring in the custom stuff to reintroduce the version numbers, but I'll do that later. That's going to be part of the data model I add back. But right now, it's... Yeah. All the stuff with encoding the variant ID, we're going to use Serde for this. So I'm just going to delete all this nice code I made yesterday. Or Friday. I can't remember when it was. And the complement, the Deserializer, we're just going to delete it all. It's going to delete all that code. We're going to let Serde do this for me. All right, kind of what I started with on last Friday. So all this stuff goes, right? I don't need any of this junk. Okay, so really then I don't need to implement anything. It's just going to be a plain old data structure for now. Okay, and then I do need to derive serialize, deserialize, which we're going to import from Serde. Use Serde, serialize, deserialize. Thank you for the follow. I appreciate it. All right, now all the errors are going to say, well, okay, this can't be serialized, right? So I need to derive serialization for message content as well. And the same thing with log entry, right? Yeah, serialize, deserialize. So that also needs Serde imports. All right. Okay, so then instead of doing that, what we do instead is we will pull in my other crate, right? Use serialization. Should I rename these or just keep them? No, actually what I want to do is do from bytes and 2 bytes. That's what I want. So that I can just say message in 2 bytes. That's not how it works, right? It's 2 bytes message in. And I have to borrow it, don't I? Yeah, wait a minute. What's wrong here? The trait dummy command is not satisfied. Oh, did I miss that on dummy command? Shoot. Yeah, so I need serialize, deserialize. Cool. So I do need to borrow it though, right? Yeah. So then to deserialize it, it's from bytes. So from bytes, serialized message. And I think I need to put this in front here. And these are fallible, right? So I need to, actually, I'm going to unwrap this one since it should never fail. This one already has a check to make sure it's okay. And this one should... Actually, I might not need to do that. Let's see if it figures it out. We need to borrow the deserialized message, yeah. Yeah, okay, it does need a type annotation. Message. Actually, not there, right? We can put it here. Dummy command. There we go. You see I'm importing the macro Serde JSON? Yeah. 2 bytes. I had 2 bytes remained fallible, though. Because that was the convention. Why not just unwrap instead of checking for OK and then unwrap? I don't know. It just felt wrong to call unwrap. It felt right to do an assert is OK. I think it's a personal preference thing. Personally, you just unwrap in tests. I don't know, this felt right to me. I don't know. This way I don't have to say it's a result message when I put the type inference on it. Actually, I guess I wouldn't need it there anyway if I did unwrap. Yeah. If a test panics, then it fails. I don't know. I don't have a strong preference for doing that. It just felt right at the time. Let me try it out. You're saying I can combine these two essentially by saying this, and then this is basically the same as calling unwrap, right? You know, I have no strong preference for one versus the other. Yeah, I guess so. I guess what I'm used to is in Google test there was a concept of expect, where it would mark the test as a failure but continue running. And I'm kind of missing that a little bit in Rust, that there is no equivalent of that. I would have to make my own thing where I make, basically I'd have to make something like struct fail flag bool fail, or fail bool implement fail flag drop for a fail flag, and then what's the syntax for drop? I forget, so I had to pull it out. I need something like this. Maybe there's a crate that does this for me. That would be cool. I want to do something like assert not self fail. And then I need to define some kind of expect macro that would use the fail flag and set its fail to true. And then it would escape the scope of the function, call the drop, and then cause a panic on exit. You know what I'm saying? That's kind of what I'm missing from Google test. You never panic and drop handlers. Well, how would you mark the test as failed and continue without panicking if panic is the only way to fail a test, though? That assert will just exit the process and you'd probably not get a test report. So maybe there's a more clever way to do it, but yeah, I can't think of a way to mark the test as a fail but continue. So I'll just give up for now. All right, so then I want to do the same kind of thing everywhere, right? So in a sense, I could just take this and this replaces this everywhere. And then the deserialize, actually, this entire set of 2 lines replaces this, right? Everywhere. That didn't work at all. It replaces these 3 lines. Nope, that didn't work either. Okay, let's just do it by hand. That replaces that. And that. Why would you want to continue? Maybe I'll let the Google test guys explain it better than I could. Google test. Since I'm a little bit tired, I would just reference their explanation. Docs. Primer. Expect. They allow more than one failure to be reported in a test. They're actually preferred by Google. Usually. And they use assert if it doesn't make sense to continue when the assertion in question fails. So like one thing I can think of is maybe you have a set of 100 test vectors. And this test vector 74 fails. Okay, so you go back and you fix test vector 74, but then 76 fails, and you go back and fix it. And now 82 fails. If you used expect instead, you would run the test once, and you would get the set of 7 tests which fail, and then you go fix all 7 before you run the test again. So it's just I think it's just another kind of preference in workflow. So Google tests their convention that they prefer to allow more than one failure to be reported in a test. And that's just this different from the Rust convention of first failure panics and stops. That wouldn't work with the Rust type system? To make a different function? I mean, you could also argue that this makes tests fatter because they're testing more than one thing. So, you know, I'm not strongly preferring one way or another. I'm just used to Google test where you would mark all the places where it failed, and you see them all. Here, let's say I have a wrong number for the term. Now it's going to fail, and I won't even know if the sequence number was correct. Right? I could combine them, of course, and compare the whole tuple. Maybe that's a better way to do it. I don't know. But yeah. Let errors equal vector run test push errors. All right, so basically collect all the errors and at the very end assert that there are none, and then you'd see them all. So yeah, that sounds like it requires a little bit more scaffolding than is built in. It would be cool. What I'm saying is it would be cool if they had a macro that did it. If using a macro like that pulled in some extra scaffolding, like what you're saying, that it actually collected the error and like held on to it along with other places where we have expect, and then at the very end it would maybe check that the list was empty. You wish Rust had table-driven tests? Yeah. It's essentially, if a series of expects is like building rows in a table, and then at the end making sure the table is all good, right? Ghost test runner does that. It influences G-test heavily. Yeah. So it's just, I guess I can say this, the Rust, it's cool on the one hand that it's all built into Rust, but the disadvantage is that it's not as feature rich, and I had gotten used to some of those features. Okay, what did I do wrong here? Oh, this is just old. 2 bytes. No, deserialize is from bytes. Yeah, that. And, okay, this one actually should error, right? So here I actually want not to unwrap, but to make sure it's an error. Okay, serialized message. Why did that not work? Oh, yeah, this is result. Actually, I wonder if I could turn it around and say, no. This should be error, right? I need to have a... I do that. That'll work. fill in the error for me. Okay, what's wrong here? Oh yeah, for this I need to do as bytes. Okay. All right, continue. That and that and that. All right, cool. So this is going to use my serializer with the Serde generated serialized, deserialized code. So let's try it out. Run those tests. 23 errors? No, we have more compiler errors to deal with. Cannot find derive macro serialize in this scope. Did I misspell it or something? Serialize. Oh, I know why. This is the third time I've done this. It's not intuitive to me, but you can't just pull in Serde. You have to pull in Serde and then add the feature for it. I do that here, right? Features derive. You need that. Now it should work. Oh, and I have another compiler error though. What's wrong here? Oh, command probably doesn't derive these traits. Yeah. Now it does. You think there is a table-driven Rust crate? There's a bunch of different test runners for Rust. The cargo test, the standard test runners, is simple on purpose. Your unit test should test as small a unit as possible. Yeah, that's what I was thinking. Like the way G-test kind of guides you towards. I closed it, but they guide you towards having multiple checks in the same test. Kind of leads to bloated tests, right? Whereas, like, if you find that you want to have multiple reports at once, then you're kind of guided towards making multiple different tests, right? Maybe you have a common setup for all those tests, but you test something different in each one. Doing a series of tests is just like 6 extra lines, like you had above, yeah. Where you use question mark to mark it as a failure, yeah. Early return, right? Unwrap is a hard guarantee the object is valid. If it's none error, what do you do for the rest? Yeah, that's when I stop and think about it. It's like if there is an error, the only thing I might care about is what kind of error it was. But if I know it's a success, I know it should be a success. Yeah, the most I'd ever want to know is, well, if it's not a success, then what is it? So, but then you can do that with a debug, right? I can in the test. Before I unwrap it, I could slap a debug on it, right? I can do this if I wanted to see what kind of error it was before I unwrapped it. I could just do that. Then I would see, okay, it was some kind of error. In fact, I don't know if when this panics, does it actually say which error we do get? Because I would like to see that from these tests. I guess we can check that. Anyway, I want to run my test again. Oh, we have a failed test snapshot. Is that because I didn't finish that one? It panicked on unwrap. Type unknown test. Okay, I think we're having 2 different tests collide on printing. Which one was that again? Install snapshot results. Run that one. Now it's passing. Is this passing sometimes, failing at other times? Or am I just picking the wrong function? No, I picked the wrong function. Okay, so it's install snapshot that failed. Panicked at the unwrap. The error is type unknown. Oh, okay. So it does print out what kind of error it is. See, it says type unknown. I wonder if it's this JSON thing in there. I think probably the JSON value, how they serialize or deserialize, requires that we encode types, right? The way I want to actually encode it is to put it into a string. Okay, so yeah, this is going to fail until I customize the serialization. But that's sweet, though. Let me check to make sure the serialization is what I expect. So for one of these very simple ones, like this one, let's look at the serialization. So debug that. This should be a very compact message if I did it correctly. Yeah, there we go. That's what I wanted. With bincode, you don't get that compactness unless you turn on a special option for it, which I didn't even know about on Friday. By default, every integer is like 8 bytes, and so there are a whole bunch of zeros, but that's almost exactly the same as what I have in C++. I think I have the sequences out of order, so I need to fix that. Like, it was the type, and then the sequence, and then the contents. Actually, I don't even know how I'm going to do that, right? We can't break apart the type of the content from its content, from what's inside of it. I think I might have to punt on that one. JSON object goes to a map. Well, it could, a JSON object could be many different types of things. Probably what JSON wants to do is encode the type and then the value, right? All right, so maybe that'll guide the custom serialization, is trying to get this test to pass. It has a JSON in it. So we want to actually, when we serialize this, make that a string and not a JSON value, really. Uses visit map, then delegates to the struct code in Serde JSON. Ultimately, it's going to my, where I'm throwing the type unknown, right? In the deserializer. Close. It's going to go to where I'm throwing type unknown. Right here. It's going to go to deserialize any, I think. Or deserialize ignored any. I bet you it's hitting that at some point. Let's see it. Debug. So I bet you the JSON deserializer, yeah. If we follow the stack trace, I bet it's JSON's deserialized code. Yeah, look at that. We are in Serde JSON and they call deserialize any for visiting the value. Yeah, so they have a custom deserialize that calls any. So that's a problem for me. Yeah, so I'm not going to go through their serialization. I'm going to tell them to go to a string and then we'll serialize that. Okay, so let's make that the first goal. That's not too hard, right? So our goal is to not enter here by customizing how we serialize and deserialize message, specifically this variant, so that we actually, in the data model, instead of that being a JSON value, make that a string instead. Actually, that means I can just focus on this variant alone, right? Can I implement serialize just for one variant? Like, can you say something like implement Serde serialize for one variant of this? Can you say that? Is that legal? No, it wants a type. So the closest I can get is that, correct? And I have to provide the type argument. So that means I need the type argument there. That's as close as I can get, right? Maybe look at the attributes that Serde provides. Oh, you're saying I could override the... I can add an attribute there and say, hey, I want to do something different, rather than diving into that directly? Because what I'd want to say is something like, hey, Serde JSON, please encoding, make it a string or something like that, right? Something like that. Pseudocode, right? I want to say, turn that into a string when you encode it. Yeah, that's, I think, what I would want. Shall we take a look? Serialize with, okay. So we'll have to go visit Serde JSON, won't we? Or is it Serde that I care about? Would it be Serde? It would be because it has to do with this serialize, right? Yeah. That's my library. This is Serde. Okay, so then, where do we go to learn more in this crate? Can I go to the top level crate, please? Thank you. Should be that one. Field adders. I'm just looking, how would I get there from their top level docs? Is it serialize? It doesn't look like the documentation was meant to be a guide for attributes. You can't from the docs because they don't build with the macros enabled. Okay. So probably what they want me to do is go all the way back out and go to their documentation. No, maybe? Or their homepage. Attributes. Yeah, you guys were directing me to field attributes, right? How about I read through all of them? Yeah, okay. You have to go through the book or build the docs locally with a dry feature, yeah. Well, they have their own book, right? That is what I want, right? So container attribute applies to the entire struct. Variant applies to one variant, field to one field. Makes sense? Okay, so we can rename if we cared about names. Rename them all. Deny unknown fields. Always errors during deserialization when encountering unknown fields. So that doesn't matter, right? Use the internally tagged enum representation for this enum with the given tag. I don't know what that means. Let's click to learn more. Consider the following enum type. The default representation for this enum is called the externally tagged enum representation. Written in JSON syntax, it looks like request ID method params. Characterized by being able to know which variant we're dealing with before beginning to parse the content of the variant. Okay, that makes sense. It allows it to work across a broad range of formats. Yeah, that's what I'm going to use too. Yes. Internally tagged. Oh, I see. Where you have request type is request. Okay, I know what they're talking about then. Adjacently tagged. I've used this one too in JSON. Or untagged. So it tries to match it by looking at fields, looks like. Okay, so I don't need that. I understand what it is now, though. So that's internally tagged and adjacently tagged. Got it. And untagged. Got it. Okay. Where clause for the serialized and deserialized impulse. This replaces any trait bounds. So we can, okay, so we can have custom traits if we wanted. When deserializing any missing fields so that we don't care about. Any missing fields should be filled in from the object returned, so we don't need that either. Remote types. What is that? Oh. Deriving it for a type in a different crate. Alright, so we don't care about that, right? Serialize and deserialize a new type struct or a brace struct with one field exactly the same as if it's one field were serialized and deserialized by itself. I see. But it doesn't matter because my serializer does that already. Is this what I want? Deserialize this type by deserializing into from type, then converting. This type must implement from type. Because, okay, what does JSON, Serde JSON implement? I should have had that open all along. API reference. I want value. Value. What do they implement from? Or actually, I want into, don't I? So, because I really want from JSON. Or maybe that's what I want, from string. Yeah, I think I want this to be from string. But that controls serialization. I need to... Oh, here we go. That's the opposite. So I need from string into string, right? They'd only do a string to value string. I think that's what I want, right? Because the from string... Oh, no, you're right. That's the wrong one. What? Okay, I got confused about this on Friday. There's a method pair to go to and from the encoding. And yeah, it wasn't any of these. What was it? Was it the display trait? It's a display trait, isn't it? And then what's the opposite of the display trait? It has a from value. Well, display is JSON the term JSON, when I say that, I mean JSON value. So this is to go from JSON value to its encoding as a string. So I just need to find the opposite of this. To go from the encoding of the string to JSON. They probably tell me at the very top of their crate, right? All the stuff that I skipped. Okay, it's from str at the top of their crate. So outside of value in their crate level, they have a from string. So, okay. That's what I have to call. I can't use a trait then. So this won't work. It's not a type, it's actually a top level function. From string. Actually, they also have it for toString. So probably instead of the display trait, I should be using toString. Yeah, so they have crate level from string to string they need. Yeah. Okay. So then I know you guys are telling me that it's in field level attributes. Still a container attribute. I'll get there. I just want to understand all of these, and I want to, so we could use from and into if we if the types were convertible with from and its complement into. I understand that. Okay, so we're moving on to variant attributes. So we can rename a variant if we want. We can alias it, rename all. Okay, so by convention, you could have a different naming convention. Skip to never serialize a variant. Never serialize this variant. Trying to serialize variant. Okay, it's an error if you ever get it. Okay. Never deserialize that. Serialize with using a function that's different from its implementation of serialize. Okay, so maybe we can do that. Right, because, well, if it was a whole variant, we could. But yeah, if I'm imagining a variant and I need to serialize it differently, this is what I would do, right? Deserialize with. Okay, so you could do with, and then you provide a module, okay. All right. Yeah, I'm sure we can do it with the field, but I'm trying to read through and understand it for later. Borrow data for this field from the deserializer. I got it. So if we know we can do that safely. Other. Deserialize this variant if the enum tag is anything other than the tag of one of the other variants in this enum. Only allowed on unit variant inside of an internally. Okay, that's weird. Okay, that's hurting my brain. Neon Ray Tracer. Hello. Rating with the party of 5. I can explain what I'm doing really quick since I've done this a few times. I have a little cheat sheet right around here. I'm learning and using Serde, Serialization, Deserialization framework in Rust, the language for encoding data structures. And I have some data structures that I want to encode for network communication between nodes in a raft consensus algorithm. So basically from a 10,000 point view, when we talk about Serde or serialization, we're talking about taking data structures and transforming them down to like JSON or text or a byte string, something that is encoded so that you can use it in a different context. So common context could be saving it to a file, sending it across a network connection through a pipe, that kind of thing. I'm going to use it for sending messages across a socket. So the messages started as data structures, and they need to become byte strings for me to send them. And then the other end, I want to get data structures back. So Serde lets us do this. There are two steps in each direction, right? There is an internal representation of data so that we can separate the data format, the encoding, from any semantic meaning of the data structure itself. So the data structure itself is in charge of dictating how to kind of digest the structure down into the data model, which you can think of as an intermediate form that just has elemental types. And the serializer only understands elemental types. So once you get the data structure kind of digested down to a data model, the serializer knows how to turn that data model into the encoding, right? So earlier in the stream, I actually wrote one of these serializer, deserializer pairs for something that's similar to the bincode crate. So we get a byte string out with some custom compression for integers that I like to have. And now I'm going to try to use this serializer, deserializer with some data structures. And some of the implementation of serialize, deserialize can be generated for you. And I'm trying to leverage that as much as I can. So here's one of my data structures. So by doing derive serialize, deserialize, we're pulling in like auto-generated code based off of the structure we define here. This is the content of one of the messages in Raft, right? So each of these corresponds to something that one member of a Raft cluster can send to another member of the same cluster, right? So this works except for this field here because the encoding that I picked doesn't handle JSON values.
because JSON values needs a feature my serializer doesn't support. So what I really want to do is say, encode this field as a string. So this isn't valid syntax. I'm right now, right when you rated me, I was reading the manual to learn what the proper attributes are, but chat is encouraging me to set the proper attributes so that we encode this as a string and not as a JSON value. In other words, to go through the Serde JSON's toString first and then serialize the string. So that's what I'm learning how to do right now. Isn't gRPC something like this? Yes. So gRPC, protobuf, they're all similar. This is a Rust-specific framework. So there's probably a Serde implementation out there for Google RPC. I wouldn't be surprised. The ones I know about are bincode. So the one I made today and yesterday was pretty much the same as bincode, only a bit simpler. It has fewer options, and it's it's something I use to learn this stuff. And then another popular one is JSON. So the top level crate for JSON, Serde JSON, lets you actually, it's more than just serialization. They also let you write JSON directly into Rust using a fancy macro that looks like this. So that this JSON macro, you can actually write real JSON in the midst of Rust syntax, and you get at runtime a JSON value object. Yeah, so there's probably other serializers out there. So Museum knows it. What's it called, by the way? Is it just called gRPC? We could probably find it. I bet you if we searched gRPC. There we go. Rust implementation of gRPC. And they probably use Serde. How come it doesn't show it using Serde? Should I be worried? Oh, this is the protocol. What we want is actually the something lower level, right? This is the actual protocol. So this probably, yeah, this probably uses, this doesn't use Serde either. Maybe protobuf does. There we go. So Rust implementation of Google protocol buffers uses Serde optionally. Looks like you can use another crate too instead. So yeah, it's all interrelated. gRPC uses protobufs, yeah. Okay, so that's what I'm doing today. I spent a while doing this earlier. Now I'm doing, no, not that, this. Now I'm doing some of this and some of this to try to get this message type to work with Serde with my encoder. So back to the book, I guess. I was reading about field attributes because I need to find the right field attribute. I think we're almost there though, right? I don't want to rename. I don't want an alias. A flatten, skip, none of that. Don't I just want one of these and give it two functions? Or maybe if I did it with a module, I'd have to have a separate file. But that wouldn't be too bad, right? What if we try the module approach? So I will say Serde with, and then it wants a string here. Let's say JSON encoding. And then it's going to say that that needs to be a module that exists, right? So we'll make a module. Make a module, which is just a file. It's a fancy way of saying file in Rust. You can do it with an inline module. Well, that's true, but hey, let's keep it as a separate file because then that's more fun, right? So it wants me to have in this module two functions, right? Serialize and deserialize. So function serialize. I have no idea what the signature of the function is. Deserialize. What does it want in these functions? Okay, it needs to be callable as this. So that should go here. Serialize. Okay, so Serializer. So that's the trait, right? So I want to do use Serde Serializer, I believe. And is that what I want there? Something tells me I'm off in my syntax. Is it just because I'm missing the body of the function? Okay, I'm missing. The syntax here is totally wrong. Public function serialize. This is totally. I'm off somehow here. I expected a name. Oh, does the name go there? Okay. Thank you, Sarian. You know, I still have these moments where the syntax escapes me. Okay, what does it not like about these types? I need to have a T, I guess. Why did they not say that here? What's T? Although it may also be generic over T. Oh, I see. It's whatever type I want. So we don't have to be generic. I can make that a use Serde JSON. What? How come it's not auto-completing for me? Help! Oh, I probably don't have Serde. No. I do have Serde JSON as a dependency. How come it's... Do I need to declare this module here? I probably do, right? Mod JSON encoding. And this will probably need to say super. Yes, okay. And then now this will resolve. Nice. Okay, so I want value as JSON value. And I should just say JSON value, right? Okay. Rust Analyzer ignores unreachable modules. Yeah, I'm figuring it out as you're typing it. I'm figuring it out too. Reading my about, I think I like system using. You used less than 270 megabytes when fully booted? I mean, that's awesome. How do you get away with only 270 megabytes of RAM? Like a custom, you have a stripped down Linux that is really conservative on the memory. That's pretty cool. I should give you one of my waves. Hi. Well, I didn't wave to not Pikrua. Hello. Atomic Nibble. I didn't wave to you. How long ago did Atomic Nibble join? At 43 minutes. Oh, that was a while ago. I'm sorry, Atomic Nibble. 15:43. There it is. There's your long overdue wave. And some other people I didn't wave to. Netcronus said hey. Sorry, Netcronus, it's been a while, but here's your hey. Hey. Along with Samfurge. Good day. Sorry, that took me a while to acknowledge. Arch and awesome WM. Just conservative by default. That sounds cool. Yeah. Well, if you can get it under 640 kilobytes, I'd be really impressed. All right, so I need to figure this out, right? This it doesn't like because I need to give these names. Value is that. Serializer, I guess, is that. Okay, now we're getting somewhere. This is just because it's not done yet, right? Okay, cool. So I got the signature of the function working, I think. The deserialize, though, it needs something, right? Yeah, when we say with, that means that it implies that we need the deserializer to match. Okay, so then, what is the signature of that one? Here it is. It's going to look like that. So it's going to be there. Deserializer D. Okay, we need to bring in Deserializer. And T is JSON value. And that's not correct because we don't have a to do here marked. Okay, so now everyone's cool. We don't have any compiler errors anymore. So this should, if I understand correctly, when we go to serialize this particular thing, it should delegate to my functions here to do it. So that means when I run my test, I should hit that to do. So let's try that. I run the test, it should hit the to do. It did. Perfect. All right, and now we get to say how to serialize it. We can just say, take that value. No, it's the other way around, right? It's Serde JSON to a string value. And then that's the encoding. Because I can only have one thought at a time. Once we have the encoding, then I need to serialize that. So that would be serializer dot serialize string. How can I tell it that it owns it? No, I don't want to do this, right? I just want to Serde serializer. No. Okay. It is one of these, right? Is it just serialize? How come I'm having a brain fart here? X monad? We've been talking about monads all today. I don't know enough about it. And that's a different kind of monad, isn't it? So it's just coincidence that we've been talking about that. Later, if you want to cheat. Okay, well, let me bookmark that. And what I'll do is I will compare my attempt to yours and then see how close I got. Something tells me I'm supposed to not call something on the serializer, but give the serializer to the value, right? Is it encoding.serialize? And I have to say, like, the encoding had better be, it's a string, right? Oh, I need to do that. Then that will make more sense. And I can't do that because the error types are incompatible, right? Yes, so I can do a map error to, can I say S error encoding? What was it? There's a, hold on. Hey there, NetChronos. How are you doing? And PhD Horrible. I haven't seen you yet today. Hi. You just can't get into Lua? You just can't get into Lua? That is sad. Okay. There was a... I don't understand this completely, so I'm going to look at it. That's my error type. No, it's... Look at the wrong one. I need to look at Serializer's error type. Yeah, this guy. Yeah, this thing right here, right? Custom. So I should be able to call a function custom on a message to return self, right? So I should be able to say custom help. I can't say custom. Oh, it's an associated type. It's not in scope. We need to bring it into scope. So I need Serde der error. Can I just bring in error as that? There's no Serde error at the top level. I have to do Ser error. Uh-oh. Oh, yeah. I need to say, let's Something like that. Okay. So then, uh-oh, the dog has been triggered. Triggered dog. Triggered dog. Right, Serde has their own type of error. Can I just tell it to I should just stop guessing and I should look back at Serde, right? Error handling. They talk about how to do this. The implement display, so I can just say error to string. Yeah, that'll work. Okay. Just something, I don't know if, yeah, that's good enough, right? And so basically to make it, I'm surprised that they didn't make a Serde compatible error, that they're making me do that. Anyway, given the encoding, we want to serialize that, right? With the serializer. And it's going to tell me I need to import something else for that, right? I need serialize. Oh yeah, I didn't bring that in. There we go. All right, got the serialize done. Probably want to do the same thing for deserialize. And I'm probably going to want the day error as that. All right, so it's a similar thing, right? First, I'm going to get a string. Let encoding equal, we want a slice, right? If we can get it. Equal, how does this work again? I forget. How do we do this? It's just deserialize given, right, the type deserialize. So it's, so I can say string deserialize given the deserializer. And that might have an error, right? So actually that error should be earlier returned. I can't do that though. Oh, do I have to say like slice? Okay. Is that done this way then? No, I have to call it on something, right? Oh no, this is almost right. Oh no, that's gonna call itself. Ah. Okay, thank you, Musen. So Musen is one of the most knowledgeable people I know about Rust. So I was close then. I was close. I almost had it. I just didn't have a reverse turbofish. Okay, so now if we should get a slice out of it, and then from that I can turn around and ask Serde JSON to do that, and now I need to map their error the same way, right? D error. Almost. I probably need to wrap this with an okay or so. What's it going to tell me here? Did I get the... What's the type here? Let x equal... What is that? Unknown. Probably because it doesn't compile. Now, can you tell me what x is, please? It doesn't know what that type is, but the type should be a result, right? With JSON value in it. Oh, so I don't need the early return then. It just is the type I want. Yeah, there we go. No, we actually want, it already is the type. This already gives me the type I want. So that's the tail of the function. Oh, if I do a let equal that, I get the type? Oh, in the error you mean? That it expected something? So that's the type I get, right? Well, that's a clever trick. I've been using the trick where I give it a name and then I look over it to see what the type is. Actually, that's close. It just says unknown for some reason. Probably because of this. Why are we back to an error here? Because it doesn't know what type I want. Okay. Weird. Actually, here it doesn't tell me the type either. Probably because it's ambiguous. Anyway, that gives us the what we want. Right? Do let a unit equal foo is the worst way of doing it. Some types are unit. Okay. Not that it'll help with Serde's magic. Anyway, we shouldn't really rely on the type deduction too much. We should know what our types are, and we should know that the from string should give me a result t, where t is JSON value, and I just I'm just really mapping the error type, and once we do that, we have the correct type. Okay. Now, all of that set aside, let's run our test again. Hey, it passes this time. And if we really wanted to see the encoding, I could do that, right? By putting a debug here, and we'll see the encoding of our message. There it is. There's the raw bytes. So let me see if I can show these side by side. So this is leveraging my serializer, right? So my serializer, for an integer, if it fits in 7 bits, it just prints it. So that's why we have term 8, sequence 2. The 4 here, my serializer, the first byte it does is the variant number. So that's install snapshot should be the 5th one because it's 0-based. And then the contents is just, again, the values. We don't hold on to the field names or anything. So the 2 is this last included index. The 7's the term. Snapshot, here's where we get the... this has to be turned into a string first, and then here's the the way I encode strings is length followed by the contents. So it's 13 characters, and I wish I could see this as a string and not numbers, but that's probably opening brace double quote FOO double quote colon double quote BAR double quote closed brace, and then that's it. And if I wanted to get it any denser, we wouldn't encode it as a string, but we have some other kind of fancy encoding for that. I am happy with that. It's working. What if you round trip it? Round trip it. I mean, you can't read raw ASCII values, for shame. I could read them in hexadecimal. Like, I know that 20 is a space character, and I know that 30 is 0, so it's convenient. If you ever see 3x, or 3y, then the y is a digit. With where y in 0 to 9, right? And I also know that 41 is capital A. And was it 61 is lowercase a? The ASCII table is conveniently laid out for hexadecimal, right? So there's exactly 20 hex reserved characters, and then there's exactly 10 hex special characters before the numbers, and there's the oddball I think is the A, because I forget what 40 is. What is that? It's like a punctuation sign of some kind. That's my experience with ASCII. I can't remember the decimal ASCII. This is why we have Google or Bing. Yeah, this one. Oh, it's the @ sign. I can never remember that one. Why they chose to put that there beats me, because otherwise it lines up really well that the digits start with 3 and the uppercase starts with 4 and then lowercase starts with 6. Except for the oddball, 60 and 40. That's backtick, right? Yeah. Yeah, it's like arranged to be letters, numbers, letters, and it fills in punctuation everywhere except for the oddball ones, there and there. It has to do with keyboards? Yeah, there's probably a historical reason for that. But yeah, whenever I have to like think in terms of ASCII, I always prefer hexadecimal for that reason, because I can almost, like, I know that E is the fifth letter of the alphabet, so it's really easy for me to fill in that that's 40 or 45 is E. If you remember which letter of the alphabet a letter is, then you can find the hexadecimal ASCII really quickly. Anyway, I'm really happy about this. Let's check it in. Git cla. Actually, this shouldn't have any changes, right? Because we moved up to the raft crate. And we're going to say we dropped all the custom serialization in favor of Serde and custom serializer. Right, so now we're using Serde and our own serialization library. So we have to derive those extra traits. And here's how we serialize now. So all that code got removed. I'm happy with that because now I don't have to deal with this custom crap. I'm really happy about that, actually. I'm so happy that I might just call it and not mess with the serialization any more than that JSON thing. That's the only oddball, right? Okay, so we're going to say here, drop all custom, well, not all, drop most of the custom serialization code. Use Serde for implementing most data model translation for message, command, etc. Custom, we'll add custom serialization. Add custom, what do we kind of call this? Field. Custom Serde field attributes. Attribute and associated module for handling JSON values in serializable data. Use custom serialization library for underlying data format. Okay, and the overall summary. What else do I want to mention here? That's about it, right? So it's use Serde and custom serialization library. Stage all, please. Commit. Push. I missed some chat, it looks like. Oh, didn't I round trip it? I thought I round tripped it in these tests. Yeah, we serialize and then immediately deserialize. Oh, you're saying instead of testing individual things, I could have tested message in with message out? That would have been smart. Why didn't I do that? Yeah, why did I have all this crap? Why can't I just say assert equal message in, message out? Why am I? Oh, because they're not I don't implement partial equal. Maybe that's why. I'd have to implement partial equal. Would that make sense? I would only need that for testing. Yeah, message, I can't compare messages right now, so that's why I do all this crap. But this is excessive, right? Yeah, I think it's worth it. Let's give Musin another point. So then without this could be all condensed now, right? I still need to assign it a type, don't I? Anyway, we're going to get rid of this. We wanted to get to the string not living long enough because my custom JSON like cannot produce an own value now. It has to always be borrowed. Wait a minute. Are you saying that this has a problem? This is owned. Is there a way? Oh, I could have done toString. No, you can't get a borrowed one for the serializer. You always get an owned one. This one will be borrowed, but I think this one just borrows it during construction. Yeah, see? It just borrows it during construction, and the result is an independent lifetime. So I don't think there's a problem with that. You should ideally use a string. Wait a minute. Hold on. What? Look at the TA of this one. Yeah, it's saying that the lifetime of that reference has to be at least as long as the deserializer, right? Which it is because it came from the deserializer. That's my interpretation of that. Yeah, won't I get a self which has the lifetime of the same lifetime as this? Which is passed in, right? So it should live long enough. Okay. Did I look at the example code? I did, Plasma. You encouraged me to go ahead and revisit Serde. So I haven't yet done that for the level that you showed me, but I am doing the static deserialization of all of my messages now. The only thing I had to put an attribute on was the JSON value because the serializer I picked is the one I made earlier today that doesn't support the any type. So yeah, thank you for the inspiration, Plasma. And when I get to the game commands, I'll probably revisit the code that you were showing to make sure I do it right. Yeah. So I ended up making a custom Serde serializer, which I am pulling in here. This is my own thing, my own serialization code. That's why it looks kind of, the tests are look like Raimu tests. We have our own custom serialization of integers that compresses small integers. It matches my C++ serializer, so I put it in the same library as my serializer. If you want to see that, it's github.com Raimu8354 serialization.git. Has both the C++ and the Rust implementation, basically of the same thing. But yeah. Let's take a look at what Musin posted. So you said, yeah, when I got mine to work, I was going to look at this to see how it compares, right? So you kind of spent the last hour writing up a simplified explanation of what the deal with monads is. Oh, cool. Hold on. One thing is on my clipboard right now. Now let me grab yours. Oh, blinding white. Put that there. And I need to immediately turn on dark mode on this before I get blind. I'm blinded. All right. Does this happen to have a dark mode? Is that what theme is? I have no... Anybody have a favorite theme that's dark mode? I don't know. I don't know what any of these are. It's just the editor theme. None of these is the color theme. Monokai? Okay, now can I turn off Dark Reader? Ah, it's still blazing white. It did the code in that, but the UI overall. Okay, so anyway, we'll just leave it. Just the text editor field. Okay, I don't need this, right? All right, let's see what... This is what Musin cooked up. Okay, here we go. Right, so basically the difference is we used an inline module. And that's exactly what I had, correct? Wait, no, it's different. How did you get away with not mapping the error? Hold on. How'd you do that? String on a value won't produce an error? But this one does, though. Wait. This one shows me that it does produce an error. Oh, you're doing the display trait toString rather than Serde. Okay, yeah. So it's confusing to me that because it's the same word, toString, but you're using the toString function directly on JSON value, which is the display trait, which is infallible. Whereas I'm using the fallible one that is built into the crate level toString. So I have to map the error. That's the only difference, right? Oh, and then you bypassed going through Serialize. You just called us. You can call it directly. That's cool. So this is going through some extra machinery we don't really need, right? So I could have just said, instead of that, serializer dot serialize string, right? Is that what you did? Well, that makes it temporary, doesn't it? And then we're borrowing the temporary. I guess once it's serialized, we don't need it anymore, so it can be temporary. Yeah, your way is a little bit better because it's direct and bypasses the Serde machinery. The deserializer, what's the difference here? That's what I did. Only you went directly to string to do it. Oh, I didn't know you could do that. So I could simplify this then. I could say custom. Really? I could have just done that all along. Usually, Clippy tells me when I can do that. Oh, yeah, you're right. That works because custom takes something that can be converted from display. Have you noticed, did anybody notice this recently? This is starting to happen to me in VS Code, where all the white space gets removed. Like there's no white space between the where and the T, or the arrow and the self. It actually causes syntax errors when I do insert missing methods sometimes. Anyway, yeah, you're right about that. That's another point. So how many points does Musin get? Probably like 3? 3 more? I haven't gotten to the core thing you wanted to point out to me. Uh-oh, is my bot dead? Oh, I know what I did wrong. There's no user called 3. I have to do that. There we go. That's the recent bug in Rust Analyzer? Okay. So you're saying to change it to a slice and run it. So what's the difference in what I did? So are you saying I'm doing something unsafe here? Because I'm essentially doing the slice version of that. Okay, so you're saying to change this to slice and change that, right? And then run it. Panicked at unwrap. Invalid type string. Expected a borrowed string. I actually ran into that last night. Yeah, I remember running into that. It was caused by what? I actually caused it. I actually caused that error to happen a different way. Yeah, here that only lives as actually. Then I don't understand it because oh, because you're using a different deserializer. Which one are you using? I guess we're using what? We're using Serde's deserializer, right? So we're using Serde JSON serializer. Yeah, okay. So their serializer gives us a borrowed string, whereas mine gives an owned string, I guess. Oh, getting all the points. Hey there, R-Driven. How are you doing? Also, forgot to say hi to Plasma. And the white. I didn't see your message. Did I miss it? Oh, you were suggesting Monakai for use in Python. Okay, yeah. I did see that one. Monakai. Hi. Yeah, thank you for the suggestion back there. So this is maybe not as safe because we have to trust that the deserializer gives us an owned string. Otherwise, this becomes an issue, right? And it's Serde's JSON that is the one wanting the, what is it? What's the error exactly? Expected a borrowed string. Expected a borrowed string. Yeah. Okay. Nope. You tell it that it must be a slice, but Serde JSON only has a string there. Oh, my custom serializer is more like bincode, Plasma. I basically wrote my own version of bincode. So it's binary, it's into strings of bytes. The only difference on the outside is they call it serialize and deserialize, and I follow the Serde convention where it's 2 bytes and from bytes. And rather than having a lot of different options, mine has just one way of serializing because it's simpler. And I have one oddity in that I try to compress integers. So that's integers that fit in 7 bits require fewer bytes in the encoding. At the expense of larger integers sometimes needing more bytes than they would otherwise need. But yeah, otherwise it's pretty much the same as bincode. Hey there, Starless Jupiter. How are you doing? Okay, I'm trying to understand what Musin was showing me here. Ah, man, that dog. That dog just like triggers instantaneously and you don't ever know why. It's not unsafe, it's just specific. The inputs must be borrowed string in mine, yes. You're using Serde JSON for the round trip, so if you do change your serializer, it'll fail. So in my case, I guess I don't need to worry about it because I'm using a specific serializer that I'm controlling. So let the string be a clone on write, deserialize, and it'll work, right? So I could do that in mine just to be safe. So that's with the right. So basically get something that's initially borrowed, and if it needs to be cloned, it will be. And then pass that into the deserializer for JSON. Okay, so standard cow, no, borrow cow, right? And the mistake I made last week was the reference doesn't belong there, but it belongs there instead, right? And then that just works, right? No comma. I hate having to cheat. Here. There's no reference. Yeah. All right. I'm cheating by looking at chat. Did I mess that up? I need to enclose the whole thing, don't I? Or do this? No, that wasn't it. Shoot. It was the turbofish, right? There, right? Because we don't have a name to give it. Okay, now this type is almost. I need to borrow it. Yes. Run. Okay. I rely a lot on the compiler telling me what I'm doing wrong. Hey, look, it worked. Hey there, Uber Unix. We're doing serialization today. Hopefully you're having a great morning, evening, during the afternoon, that kind of thing. Yeah, Musin, I'm still really bad at using cow. I don't have enough practice. And I also don't have enough practice with the left-hand turbofish either. Yeah, and you'll notice when I'm rusty at something, no pun intended, but when I'm not practiced enough, when I just fumble with the syntax. But I have the, like, I know what the concept is. I want to say, hey, I want to run through cow's definition of deserialize because there is an implementation of deserialize for cow, and I just want to use that one. So just for more practice, let me do it again here. So yeah, I know I want the left-hand turbofish, and I want to use the cow. So use standard borrow, because there's no other kind of cow other than the standard borrow cow, right? And lifetime goes first, and we don't have a name for it, so just pull it in implicitly. And there's no reference there. And then we have to borrow from it to get a slice. There we go. Just enrolled in a CCNA certification course. What's CCNA? I'm not familiar with that acronym. Or initialism, I should say, since you can't pronounce it as a word. This form of turbofish is super obscure. I've seen it a few times. Cisco networking. Nice. Serde is very particular about borrowed versus owned types. Okay, yeah. So at least they give us an error that I can now recognize. When they say something about borrowed, I'll know that it has to do with who owns the string and for how long, right? So this makes sure that this is basically saying we don't know if we'll be able to keep it borrowed or if we'll need to clone it. So give us something that'll work with either one, and then, hey, here's something that you can borrow for a while, for some lifetime, but after that you're going to need to clone it, and then it can take care of it from there, right? You can use that for a vector? Yeah, I knew about that, that wherever you see that, you can replace it with that to go between string and vec u8. I know that. What do you call that? Analogy? String is to string. Str is to string as that is to vec, which implies also this. Correct? Yeah, that's an unsized slice, and so is that. That's also unsized slice of characters. So that's a reference. And I suppose there might also be a type for this, but there's also this, which is a size known at compile time. I don't know what you do on the left-hand side of there, but anyway. I need to take a drink because I'm losing my voice. The cow gives it a size because it actually holds onto a slice, right? Yes. So what's the equivalent of that for a string? Is there such a thing? Who knows? Okay, why did I not need that one anymore? Why did I need deserialize but not serialize? Where do we use deserialize? Oh, because we bypassed the serialize. That's right. We can go straight to the serializer here. The only way to bypass this deserializer would be to to bypass this deserialize would be to make our own visitor, right? Yeah, I'm not going to do that. All right, let's move on. I wanted to make these comparable so I can eject all this redundant code, right? So I think all I need to do is derive partial equal and equal at all the different levels, right? So we'll need to do it for message content. Sorry. I haven't hydrated enough. So I'm losing my voice. Is that all I needed to do? Are we done? We might be done. Let's run that test. Cool. Now how do I break it? So, can I make that mutable and then change the term and make it fail? Verify that it actually... Yeah, okay. Cool, and it actually prints both of them. Neat. Alright, because we implemented the debug trait. Alright, I like it. I could have done that in C++ too. I don't know why I never did. Yeah, all this checking individual fields is sort of silly, right? So let's go through and clean that up. All of these tests do something silly like that. Yeah, this kind of thing, we don't need all this. I could just say, why don't I just copy it from where I just wrote it? These lines. Go here. And there. And there. Look at all that code I'm deleting. It's kind of scary. In fact, I don't even need a clone here anymore, do I? Look at that. I eliminated a clone because we didn't need it. All right, and then here. And one more. Look at that. It's very cool. Okay. Why is it saying I'm not using those? That's weird. I am using it. Why would it complain about it here? It says it's unused. Why would it say it's unused? I think it's... Oh, because because I'm using them in the tests only. Yeah, this is in the wrong place. This should only be inside the test module. Yeah, that's... Took me a minute to realize that I did that wrong. So I only need custom command inside of the test right now. Yeah, in fact, it already is there, so I don't need that. There we go. Got rid of all our warnings. And I still need to do that. Okay, run all the tests. Okay, I still have a debug in there, I guess. Yep, look at that. Left it in there. It's kind of funny how it got mixed up with all the other tests because they all ran in parallel. Run the tests. Alright, cool. 8 tests passing. Tries can save me a lot of time. Well, yeah. I still say it wasn't wasted effort because I learned a lot about how to do it by hand. I might keep that as its own module in the crate because I might want to use that elsewhere, but maybe not. It seems like this seems very reusable to me. In fact, I could give it a better name like JSON, like JSON string marshaller or something. I don't know. Okay, anyway, I think I'm done with these. I'm done with message. Oh, I should work on log entry, because that I also wanted to be able to serialize. And I need tests for that. Mod JSON value to string. But that only captures one direction. Yeah, it's close. I think I need to take a quick break, though. How long have we been going? I've been going almost 6 hours without a break. I'll take a quick break, and then what I want to do is add serialization to log entry, which is where? It's buried in here somewhere. This type. I want to add serialization to log entry, which means I want to also serialize command. Which means that this will need to be serializable. Yeah, so right now we have the old way I used to do this with to from JSON, but if I use Serde for this, this will become deprecated. I might not need it anymore. If we just serialize everything, and then yeah. So let me take a break just to get more water and all that. And if you've been sitting for the last 5.5 hours like I have, now might be a good time to take a break, get up and stretch. I think 3 minutes is probably fine, so I'll be right back after a quick break. I'm back a little bit early. Okay. All right. Let's start with some unit tests. Here's one where we're checking to JSON from JSON, right? Actually, this would be much easier expressed as that it should compare to that, right? What if I clean this up really quick? So we should just say assert equal, well, let log entry assert equal log entry comma that, right? Well, that's just the command part. Hold on. This is the full one, right? And the command part goes in there. That's more compact, right? And more correct. So the numbers are the same, right? Believe so. Yeah, I don't know why I did it that other way. It's just, I think I was just doing it when I was tired or something. That's much easier to see. So, yeah, same thing. I want a simple compare down here. This command here, and log entry is that. Right. Compare equal. Do I need this? I don't even think I need this because I derived the equals. So why am I testing a derived implementation? It should just work, right? Same thing with command, it's derived. Oh, no, it's not. Command is not derived. I actually had, I couldn't for some reason. Why couldn't I? Why couldn't I derive partial equal for command? Was it because of the custom? I can't remember now. I shouldn't need to do that, right? Hold on. Yeah, that's what I was thinking too, Sarian. I don't know why I need to do this. Let's not delete it yet. Let's just comment it out. There was something though, right? Same thing with debug. There's some reason why we couldn't do that at first. Maybe I couldn't figure it out yet. Anyway, let's add this partial equal and debug, right? We should be able to do that. What is it? Just works? Okay. Debug output does differ from the drive though. Oh, what's happening to my blue screen? Just running out of good light. Let's adjust it. And this is what these light strips were meant to solve. Is it just that the camera needs to be reset? No, I got the color wrong, I guess. Okay, what color are we on? That's the color. Oh, it's the light behind me. Okay, that was my bad. Okay, hold on. I need to get up and go fix that. Hold on. Does it look better now? Yes. Okay. Problem is that this blue screen behind me is semi-transparent, and if so there's a lamp behind me in the next room, and it throws off the color key. So now that the lamp is off, the color's more uniform, right? So it matches the color key. So, all right, that's what that was. Okay, so then my debug output differs. Yeah, but that's okay. The debug output, I don't really care if it looks the look of it. I must have done this in a moment where like I couldn't get it to work and I didn't understand why. I almost kind of want to look back at the VOD and see what happened there. So I didn't need to do that at all. That means that these are directly comparable. So there's no need for me to have this elaborate test to make sure that they compare equal, right? This is just silly. I'll just remove it. All right, removed. You could thought the derive wouldn't work on the generic, but it does, right? As long as you derive it, which I think I do in all my tests anyway, right? Where's the dummy that I made? Oh yeah, look at that. I don't need to do that either. I don't know why I did this. This can just be derived. Derive debug equal partial equal. Yeah, see, it just works. I don't know why I went through the effort of it. It just does impl t debug for debug. Yeah, so I don't know what I was thinking. We do need custom command, those. I don't have a macro to derive that yet. Okay. Didn't I have another one embedded in here too? Here it was. Interesting, I didn't need to derive... Oh, because we never actually compared them. But the moment I do, we'll have to derive equal, right? So log entry assert equal log entry, comma, the original. Oh, I don't have an original. What is this doing again? Custom command. Actually, here it is, right? So I turn it to JSON and back. We should get back the same thing. Actually, can I just compare them then? Yes, I should be able to. So I don't need any of this stuff. Right, so for that, I think I just need to derive this. Yeah, okay. It just works. There's no need for me to be so elaborate before. I don't know what I was thinking. Probably was just tired at the time, and no one told me, hey, you didn't need to do that. So now it's much cleaner. The most of the code here is just the data inside. Okay, so now that that's out of the way, let me check that in. We have a nice clean slate here for me to add binary serialization to it. So this is a cleanup. Actually, there's a bunch of stuff here, right? Oh, okay. First things first. This is improvements to JSON encoding thanks to Musin. All right, so commit that message, right? So this is cleaning up warnings. And implementing, actually these two can go together, right? These two have the same purpose. We're removing a lot of the custom comparison and debugging. Clean up custom debug and partial equal. It's not really cleanup, it's replace with derivations. Commit that. All right. Now that that's out there, I think I want to do a test for each kind of command that runs it round trip through the serializer. Yeah, might as well just run it through the serializer, right? So single configuration command serialization. What get client is get cola. Hey there, Trixon. A viewer of mine named Enduran told me about it. It's the, what is it, decaffeinated? Get client? Highly caffeinated get GUI. There we go. I'm using that as a replacement for what I used to use, which was get GUI. That I have been using for years and years. The problem with get GUI is it doesn't have a dark mode. That works for me consistently on all platforms, but get cola does. Only problem so far with get cola is that I can't change the theme on Linux. This, where is it? Under preferences. This appearance is missing on Linux, but I think it's because my Linux machine is old, and so I have a really old version of get cola there. VS Code has a get GUI, but VS Code it has to do with decisions that I made a long time ago. If you look at my top level workspace, my git ignores every subdirectory that has a Git repository in it, because instead I use my own management system for multi-repository. Because instead of using Git submodules, I want to track by branches and not have to change the main workspace directory whenever I make changes to any of these branches. I use my own tool called Mugit. But a side effect of my own tool populating the git ignore, and the reason why I populate these git ignores is because if I don't, they show up as untracked changes in the top level workspace. So I ignore them. What the ignore causes to happen is when I'm in these files, right, and I make changes, they don't show up in the built-in version control, which I forget which tab it is. This one. So this one doesn't show this file as having any changes. It says the only change around is the cargo lock. Could use a git work tree for that. I think I tried that at one point and I couldn't figure it out. But yeah, there's like a bug that I've been monitoring in VS Code that talks about like the fact that if a sub-repository is ignored, it won't show up here, and there's no way around it. The only way around it would be for me to stop ignoring it. So if I went to git ignore and I removed Raft, for example, now it'll show up, but it shows up as a not there. It'll show up as an untracked change somewhere. Where is it? It doesn't even show it here, but if I do git status here, it'll say it's an untracked file. So yeah, it doesn't seem it doesn't seem to be set up for my workflow where I have a lot of separate Git repositories underneath the main directory. So yeah, that's why I don't use it mostly. I mean, I could use it in this top level one. I could use it for this, right? I can say update Rust dependencies. Was it Control Enter? How do you stage it? You have to hit a plus or something, right? Stage. Commit. There, I used it. Interesting use of Git. I'm not the first one to come up with that, by the way. They use that, or they at least they did use it in Android. So if you look up Android repo, this tool is exactly the same workflow as mine. Do they give like an example of it? How about homepage? Docs. So when they talk about a manifest file, do they give an example of a manifest file? They don't give an example, but their manifest format is almost exactly the same as mine because I was inspired by their tool. Here we go. Source control tools. I think at some point they justify what they did, and it's roughly the same reason I did it for mine, is that it lets you unify separate Git repositories together and track things with a manifest file, which is what I do. So basically, the Git repo and my Mugget tool are essentially the same idea. Do something similar on the Chromium side. Yeah, it's when you get really super big workspaces that you don't want to track in a... Well, it comes down to, do you want a mono repo workflow or a multi-repo? And I like a multi-repo. Google doesn't use Git and they use their own VCS. Very opinionated. Oh, really? Very opinionated layout, yeah. Yeah. Anyway, maybe I'll switch one of these days and not need my own tool anymore. Switch back to... It would be kind of nice to be able to have my changes show up here, but they don't. Let's speak Git, yeah. I didn't know about this Piper thing. All right, so I was going to add a test. Oh, right here. Here we go. So there's no really good reason why I had these separate, right? I could have just combined these together. I mean, it fits reasonably well, right? Yeah. In fact, why don't I just do that again here? There's no good reason to do that anymore. All right, then the idea is I would like to say let encoded entry equal entry dot serialize. No, I keep getting that backwards. I need to go 2 bytes entry. unwrap. This I need to import. Yeah. Right now, it's only the test that will do it, right? So use serialization as a placeholder name I made, right? 2 bytes from bytes. Right. And this won't work because it doesn't support, well, I didn't have references, but it's still not going to work because it doesn't support serialization yet. So we'll have to add that. But let's say it did. What we would do is we would say let decoded entry equal from bytes. Log entry. From bytes encoded entry. Unwrap again, right? Having trouble thinking right now. Compared to what I did before. What did I do? Yeah, I unwrapped both times, right? Yes. Assert equal. The decoded entry should match the entry. Let's call this original entry. Okay, so that's the test I want. This won't work until wait, oh, this has to be dummy command. Yes. So it won't work until I make these serializable. So let's do that. It's custom command that needs it, right? Or dummy command. Yes. Serialize, deserialize. Now it will work, right? Magically. Right. Run the test. Yeah, just magically works. Now, if I was curious to see what the format is, I can just debug that. It should be fairly compact, right? It's got some bigger numbers in there. So anyway, term 9, there is sum command. What's the 0 for? Oh, single configuration. That's what the 0 means, because that's a variant. And then there are, in the old configuration, 5 entities. 8, oh no, it's not. Oh no, there are 5, but these are just unsorted, right? These are the 5. They're just in some kind of arbitrary order. And that 13531 is actually probably these 2 bytes together, right? And 8354 is probably these 2. So this, or this set is the first old configuration. And then, yeah, so in the new configuration, there are 4 entities, these 4, right? These 4, and that's it. Okay. Sweet. I keep hitting the wrong button. All right, moving on. I want to do the same thing for joint configuration. Right here. Joint configuration. Joint configuration is the same as single except for it says new instead of configuration. Otherwise, it's exactly the same. Makes me think I should combine those somehow. But really, it's if I combine them, I would still need to tell a difference between joint and single somehow. Like, I could have a configuration, and then there could be a variant inside of that. In addition to the 2 configurations, it could say, like, whether it's joint or single. Maybe that would be a better way to do it. No, I'll just leave it like this for now. There's not much harm in it being the way it is. Did I leave the other debug in there? I did. All right. Let me clean this up. This doesn't need its own name. Looks perfectly fine the way it is. All right, now run that. That should just work, right? Just works. I like that. Rust Analyzer is getting better at removing debugs with control dot. Control dot, huh? Control dot. Oh. I didn't even know about that. Thank you, Musin. Another point for you. I didn't know that there was a light bulb thing for that. Yeah. Remove debug. Look at that. That's neat. I hardly ever use control dot. I should, though. What I've been doing, I've been very lazy. I just wait to see the light bulb and I click it. But you're right. I could also just hit control dot, enter, and there we go. Don't need the mouse. Yeah, the light bulb. Mm-hmm. Okay, so let's do the same thing for the empty command. This is empty command. So here the command is none. And that should just work, right? Yeah, easy. This is maybe too many tests. Custom command. I suppose we'll just tag onto this since it has its own thing. Yeah. So something like this down here. Run the command through the full round trip of serialization. Okay, so then it could be any one of these, it doesn't matter, right? So log entry. And that has to be PogChamp now. Okay, so for that to work, this needs to be serializable right here. Which is easy, because that is. So this should just work. And I'm running out of things to do very rapidly, since serialization is now a piece of cake. I guess we'll get on to, since I have more time, I can get on to actual raft stuff. Let's go to check that last part in. So now log entries are fully serializable using my own serialization, which I'm happy about. Okay, so make log entry serializable, which is really just doing that. Or really, it was mostly serializable. Let's say make it completely serializable. Oh, wait a minute. No, it already was, and I just didn't test it, right? These are all changes inside the test. Okay, so test serialization of log entry. Yeah. So I had already done it. I just didn't record that I had. All right. So the next thing in Raft would be to actually start pulling in the algorithm, right? So the log entry and the message are the fundamental building blocks for the API. Now we actually need to start building the concept of what I had in the C++ is called the server. And the server API that we want to test is where? It'll be embodied by its functions, right? That we have a way to get events out. Events can be they're up here at the top, right? Event could be to send a message, to signify leadership change, the election state changing. I'm wondering if instead of events, I should just use a channel. So we would provide a reader back, and we would be able to read out the events from the algorithm. That would probably make more sense, right? The C++ way I did was you'd register a callback function. It would be called in some kind of arbitrary context. Yeah, subscribe to events. Yeah, that's what I was thinking, sending it over a channel, right? So a channel for that. So then here is dependencies. We need to provide something that can keep track of a log of events, a sequence of log events. Persistent state has a few things in it we need, right? Current term, voted for, So I need to implement a persistent state. I need to implement a log keeper somewhere. Oh, no, those are abstracted away. So yeah, these are true dependencies. We don't need a scheduler, I think, because I'll just use futures crate and futures timer crate. Cluster config, what is that? Oh, right, we already have that. That's just a set of ID numbers. What's server config? Okay, this, I think we will just make this something that's like the mutable part of the server. Actually, some of these can't be changed once it's joined the cluster. We can't change our instance ID. We can change our timeouts, though. We can change our heartbeat interval. Yeah. So some of these we can change, but this one we can't. Actually, technically we could change it. It would just be disruptive to the cluster. We could let them do it anyway. So we could just make all of these things public in the server, right? If you have a mutable reference, you can change them. That's probably what makes the most sense to me. If you have a mutable reference, or if you own the server, then you can change all of these. So these would be in the public API then. I don't want to mess with builder pattern. Anyway, I guess I do want to keep the demobilize pattern, because that's how we give it its dependencies. And how it releases them there. Okay, so we need an API. So I'll probably implement sync instead of this, right? That it can be a sync of received messages. Oh, actually, these are all different things you could sync into it, right? Append log entries, change configuration, yeah. Yeah, so I think it will take a channel in which you can tell it to do things while it's running. All right, so then, now that I have all that all in my head, should I start to do it with test-driven development? That means we're going to want a server.rs that is public. Does this sort them alphabetically, or do I need to manage that? It does. Okay, cool. I'm glad that you do sort that. Thank you, rustfmt. And then we're going to start with, as I always do, configuration test mod tests. Use super everything. All right. The first test. I already have tests, so I don't need to invent them. I can just copy them over. rustfmt will sort unless you put a blank line. Yeah. If I have it configured, yeah, which I do. Really, a blank line will prevent it from sorting it. So if I put it there and I put blank lines around it, it won't sort it. Oh, yeah, look at that. Well, that's neat. I didn't know it would do that. Okay, so looks like I actually have several different subcategories of tests. Does that mean I ought to have several values, several types? I think no. These are just different categories of tests. So that tells me that I want to break up my tests into submodules. So I will want to have a module called server. And in there, we would do this. Well, these two lines. And it's no. I'm doing this wrong, aren't I? Server would have a module called tests. Yes. That's where we would put this. And then this has to say mod. Actually, the configuration goes on this, right? And then that will find this. And then under here, I would have tests. And I would have mod common. I'm just trying to replicate the test structure I had here, where I had common tests, election tests, reconfiguration, and replication. What did common have in it? Was this just fixture stuff? Oh no, there are common tests. So like mobilizing twice does not crash. Yeah, this stuff. Okay, so we will have common tests. So that means I will have under tests, I will have a common.rs. Yes, okay. And so I'll want to repeat the use super, right? At this level. Okay, and then let's pull in one of the common tests. Okay, it looks like I have elaborate mocks for things. I probably want to break those out as separate modules, right? Yeah, that's really crazy. I'll try to avoid that craziness this time with Rust. Okay, so this test is that we can mobilize the server. When we call mobilize twice, it doesn't crash. Easy, right? So function mobilize twice doesn't crash. Did I turn on inlay hints by mistake just now? I think I might have. Okay, so anyway, we have let server equals server. I don't know. How would we want to create it? I think we should just be able to make any server at any time. So would that just be default or new? It doesn't really matter. I can implement both. Anyway, server.mobilize. Server.mobilize. Make sure it doesn't crash, right? That's all we need to do. All right, so that means we have to be able to create a server. Server type has to exist and has to have a function mobilize that we can call twice without crashing. Easy peasy. Start with the easy stuff, right? So let's do it. Struct server. Impl server. This is pub. Pub function new returns a self. There we go, self. And it also has to have a function mobilize, which doesn't need to do anything. Thank you for the follow. And hey there, K-Mamala, 91, hey. Neon Ray Tracer sent you here, huh? You're watching a stream? Yeah, he rated me a bit ago. So I was working on serialization earlier. And just really briefly what that was, you might have missed. Since we're working with the Rust programming language, the Serde, or Serial Deserialization framework in Rust, is for encoding data structures. So, for example, if I point you to the example in the top of the Serde documentation, if you have a structure like a point here with x is an integer, y is an integer, serializing it would be like turning into like a JSON string like that. And there are two pieces of it. There's first taking the data structure and converting it into the data model. And then once you have a data model, running it through a serializer to get the encoding. Okay, that's the phone call I got to answer, so I'll be right back. Yeah, that was Mrs. Raimu. Serde used to be built into the language, is known as Rust C encodable. Ooh, interesting. Anyway, what was I saying? So, two-step process. Turn your data structure into a data model, and then the data model into an encoding like JSON. You don't, in these examples like this, where you go from a structure straight to the encoding, you don't see this intermediate data model. You only really see that when you're implementing either the front end or the back end, so to speak. So I implemented a back end today that will take any data model in Serde and generate a byte string out of it. So it's a lot similar to this bincode crate here. What I had to do was to implement serializer deserializer is my input to serializer was a data model, not the original data structure, right? So this data model is more or less a set of functions which I have to implement in order to turn elemental types into the encoding I want, in this case a byte string, right? So conceptually what it means is point, since it's implementing serialize, it's in charge of converting itself into a data model. So you could say, well, maybe the way point works is it just takes its x and y and just puts them one after the other. So int32 is the data model. Another perfectly legal data model would be a 64-bit integer where the top 32 bits are the x and the lower 32 bits are the y. So there's lots of there are many ways in which you could destructure the point to just like a list of a list of values that are elemental, that are built in, so to speak, and then take that and serialize it to JSON, right? The one that's, if you derive the trait automatically like this, there's a algorithm that Serde does itself to generate it, which works on most everything. The very 1% or less cases where you have to implement this yourself, or you have something weird going on where it's just not obvious what data model might work. But anyway, I implemented this stuff earlier today, and then I used it to implement a little bit of this stuff for the data structures I need for this raft algorithm that I'm working on. I mostly used the same derived traits, but I had to make one little adjustment, which was in the message at the top, where at one point I have a JSON value in one of my data structures, and I had to use a custom encoding for that. And if you want to see what that looks like, it's not too gross. It just looks like this, where you provide a serialize and a deserialize function that says, well, how do I turn a JSON value into, how do I give a JSON value to a serializer? So here's a JSON value, here's a serializer, you deal with it function. Deserialize is the opposite. It's like, here's a deserializer, could you please give me a JSON value from that? And my implementation is just to go to Serde JSON and say, turn that into a string encoding first, and then give the string encoding to the serializer. So in a sense, what this does is, instead of letting Serde JSON do the serialization of snapshot, I just tell Serde JSON off to the side, please give me a string first. And then I say, okay, now we're done with you. Now take the string and pretend that this said string there, right? So that's the one adjustment I had to make, because my serializer is not compatible with JSON value. For one of the things JSON value can do is you can have a value can be one of many things. So they implement they require me implementing the any function, and I didn't want to do that. So anyway, that's what I did earlier, and now I've caught you up. So now that was the main part of my stream, was doing serialization with Rust. Now what I want to use this serialization for is this raft algorithm. You can read more about it here. It's a fun little algorithm. I use it in the implementation of my online game for error resiliency, and well, that's the main thing, is that if you have something running on a server and you're willing to make 5 copies of it, you have 4 backups that are always kept up to date. Like if I start to update the state of my server, that state gets replicated. That's the other word, replication. So it's error resiliency and replication. The algorithm takes care of making sure that any kind of state you have in one place can be copied and kept in sync in real time with that original master instance, right? So a lot of the algorithm is the mechanics of the message passing between them, like these little dots are here depicting. So for example, if this server crashes, right, it's not going to respond to those requests. So in the meanwhile, we might have advance the state of our game of 3 more steps, say. And then by that time, let's say we reboot that server and it comes back online. One of the properties of Rust is it will catch up that server that was behind, like it just did. If the server itself, that's the leader, were to crash, then there's a built-in mechanism in the algorithm that these servers, these little progress bars that are around the circumference, they indicate timeouts. So they're randomized. So the first one to time out then tries to elect itself as leader. So it holds it generates a new term, so to speak. That's why it went from 2 to 3. And it said, hey, vote for me. And if it's the first one to get its votes out to everyone, it becomes a new leader. So the algorithm takes care of replication of state, of handling, the loss of partial state and the recovery. So if we resume this guy, he will get caught up to turn 3 as soon as he gets told that, hey, we're in turn 3 now, I'm the leader. And it also takes care of making sure that there's one and only one leader, and then it also handles partitioning. So if like 1 and 5 get divided from 2, 3, and 4, 2, 3, and 4 can make progress, but 1 and 5 can't because they're not a majority. So it handles that kind of stuff. So that's what I'm trying to implement right now. I'm not sure what the cap theorem is, but hey there, Kirkinator, how are you doing? And hey there, Papata Still Papa. Yeah, it's called a consensus algorithm. So it makes sure that when you have like numerous members of a set, that those members all agree with each other about some state. So in the case of my game, the state is all of the variables in the game, where all the players are, how much gold you have, what kind of items you have, whether or not you're alive or dead, what are your current hit points, all that is state. And my game runs on multiple copies, so that if any one instance of the game program were to crash, the game can still run as long as a majority of the copies are still running. So this underpins my entire game's infrastructure. All state transitions have to go through this algorithm in the form of log entries. So at the very base of the message passing between instances is this guy. These are the ones that are built into Raft, and then we're going to add to these commands that are game specific at some point. Cap is basically a choose 2 of 3 conundrum about data consistency. No, Raft is about majority rule. So once you get a majority of servers to say, hey, yeah, I have a copy of that data and it passed a verification step, then the state advances for the whole cluster. Until then, you keep having messages go across until everyone gets a chance to make sure that they have successfully copied the state. But ultimately, it's a majority rule with an elected leader. So in some senses, it's democratic, but in others, it's not. The leader rules, basically. It's a dictatorship. Yeah, and they trust the leader. You want in your Raft cluster all servers to be trustworthy. Otherwise, you could have the state diverge just because someone decides, hey, I'm gonna have the game cheat now. And if your instance of the game were to become the leader, whatever you say happens. So you probably don't want to use that architecture for a peer-to-peer game. In my case, I'm in full control of all the game copies. Things like Paxos, what Raft is a simplistic alternative, handle untrustable leaders. Interesting. How's it different from DLT? I don't know. I would suggest looking at that raft.github.io and the links that it points to. That's a little bit deeper than I've gotten into it. My knowledge of Rust is like, I know the mechanics of it and I've implemented it, but I wouldn't be able to tell you how it's different from anything else because I haven't used anything else. Sorry I can't answer the question. Okay, so I just need to make this minimally build, right? Okay, I'll do what it says, and it suggests that I implement default for server. Actually, I don't even need to do that, right? I can just derive it. Derive default. There we go. Now it's happy. So let's just run this Common test to make sure. Oh, we don't have mobilized. Yes. Wait a minute. I do have mobilize. Why does it not like it? Oh, it's an associate. Yeah, this should be mutable anyway. So this should be mutable. Run that. Okay, minimally pass the test, right? And we're gonna keep, even though this test is sort of silly, what it serves is that once I start filling in junk and immobilize, this makes sure we can call it twice without anything crashing. New Rust Analyzer lets you turn a drive into a manual implementation. Oh, that's cool. Missing the self receiver, but try control dot. Okay, let's see what happens. Control dot. Oh, look at that. And it actually almost did it. I was hoping that it would say call new. Yeah. It doesn't fill it out. Yeah. Okay. It doesn't fill it. It would be cool. Wouldn't it be cool if it filled it out with what the macro would have done? Because what the macro would have done is call new. I think. Just gives you all that boring boilerplate. That's true. I mean, that boilerplate is nice to not have to remember. Okay, let's pull in the second test. I don't know how far I'm going to get with these tests today because I got to cook dinner soon. Maybe I can stream more after dinner? No, I can't. I have to do World of Warcraft today. Where are we going? Common.cpp, right? Yeah. Logkeeper released on demobilize. Okay, here's where we have to start introducing more things to mobilize, actually. Yes. Test function. So turn that into that. All right. So I need to... What do I need to do? I shouldn't start saying a sentence until I am ready to complete it. Right. That was actually just a shim for mobilizing with a whole bunch of dependencies. So let's just introduce minimally what the test needs. It needs some kind of... We need to define some kind of interface for log. So let's put that at the same level here. Log. Keeper? What do I want to call it? Log. It's this interface I need to replicate, right? Right, it's a dependency object. So in C++, I use object-oriented programming with a class. In Rust, I could do it with a generic. That would be better, right? So if I made it generic over something that implements a trait, that would be better. Yeah, so I'm going to put log here, and it's going to define a trait. So pub mod log. Trait log. That's all I need for now. So let me think about this. Yeah, so the common test, I need to make a mock of this. So let me think about this. At this level, I kind of want to do a use a pub use log. Did I not make it public? I didn't make it public. Pub, not public. Log. There we go. And why don't I also do pub use server while I'm at it? All right. So then this can just say struct log. Implement let's just call this mock log. Implement log for mock log. And then implement drop for mock log. Drop. Okay, so what's wrong with this one? Can I find log in the scope? I thought I did use super. Oh, do I have to actually pull in junk? All the way up the chain? So, hold on. This should go to here, which should go to... test server. All right. Hmm. Yep. Not too long though. Okay, I guess this use isn't enough to pull in that. I'm surprised though. Can... Do I have to do pub? No, I shouldn't have to do pub use, right? Oh, hold on. I think I know what it is. Server.rs doesn't use... Yeah. So, I should use crate log. Yeah. Well, let me put it at the narrowest scope that I needed in to start with. So that would be at this level, right? Yes, okay. Then control dot. What? There's no drop? I can't implement drop? No! I think it's this problem again where it's inside of a function. Now I can do that, right? Yes. All right. That problem again. All right, so then basically what I want to do is make sure that the log was not destroyed. So just trying to keep it simple. I guess what I should just do is use a I don't know what they're gonna do with the log. They could send it across threads, so I should just make an asynchronous, like I should make a critical section with just a flag or something. Yeah. So I'm gonna want to end up ultimately using standard sync arc, use standard sync mutex, just to keep it simple. Oh, they don't, it's not formatting it because this is still wrong, right? Okay, so then log destroyed, arc mutex bool. There's probably a much easier way to do this, maybe with an atomic, but I'm not gonna... Actually, why don't I do the right thing and just use an atomic? I don't know how to use atomics yet, but I can always learn. Where's the overall... Here it is. So, atomic. Yeah, what if I just use atomic bool? That's all I really care about, right? So I can make one. Does it implement copy and sync and send? Oh, it does. So I can send that across threads and it's fine? Or do I need to box it? So I do need to have it reference counted. Actually, that makes sense because we don't know how long it'll stay alive without putting into an arc. Okay, yeah, let's do that. So then it's atomic bool. Did I get that right? No, atomic. There we go. And so, whoa. Uh-oh, cargo invocation has failed. Error code 101. I got a pop-up from cargo. Okay, I think I really confused it. That's what's happening. Atomic bool. Probably because of my C++ code. What if I comment that out for now? Now maybe we're cool again? I don't know why that opened. Yeah, okay, we're cool. All right, so that we have the log destroyed, and then I want a copy of that, right? So what comes first? How about we just make log destroyed equal arc new atomic bool new false. So Mrs. Raimu was working on something in the bathroom, and she was not pounding on the wall, and it causes the dog to start barking because the dog thinks someone's at the door. And so if you hear any barking, it's because the dog thinks someone's at the door because Mrs. Raimu is knocking on the wall in the bathroom. All right. Okay, so we have our atomic variable. Now we can let the mock log equal mock log with log destroyed is log destroyed dot clone. Yeah, that the load store for atomics concurrent exchange makes it brings back some memories. Yeah, I've heard of just use sequence. Was that CST is like I can't remember, but so it's the order of things, right? Ordering, yeah. Um, okay, now that we've created it, I want to actually mobilize a server with it. So that means I probably want to promote this out then. In fact, what if I do this in reverse? What if this has a new in it? Impl mock log function new self, and then put this there. Log destroyed that. And then actually it doesn't even need to say log destroyed, it could just say destroyed. Or dropped, would be even better. All right, and then let me move it out. I think I'm going to reuse this. I might want to even put it in its own module, but for now it's just going to live up here. Okay, so then in reverse of this would be log new, and then this is the clone. Just dropped clone. This should just be log dropped. There we go, much cleaner. Then what we're going to do is make a server. So let server equal server new, and then server.mobilize mock log. Thank you for the follow. Rust atomic model is literally stolen from the C++ 11 one. Well, it's C++ 20. Yeah, I'm familiar with the old school. I was familiar with the old school atomics, but I don't know anything about C++ 20. I was telling my friend I'll probably never go back to C++, and he's like, "You shouldn't leave C++. They added all sorts of cool things in C++ 20. Sequential, consistent." Yeah, that makes sense. Okay, so the test here is that we should be able to drop the server, and it should drop the mock log with it. Do I even need this test, though? Oh, no, it's on demobilize, not that. Right. So we have to drop our own reference to it. So drop mock log. In fact, I think I want to set up this interface to where it gets a reference to it. Yeah, so it would be just an arc. Let me think about this. I could have it internally handle thread safety, right? So it could just be arc. So then arc new. So then we would drop it after actually doing that. The arc new takes it, right? Yeah, so I don't need to drop it. So we can't. We've put it into the reference, so we've given it to the server completely there. Yeah, so I don't need to. Yeah, all right. Then I would call demobilize, and then we would say assert. This is where I gotta remember and figure out how to do this. It's I don't need to compare and exchange. Can I just get it? Okay, let's just read about it. I just want to call load, right? Ordering sequential consistent. Assert that it's dropped. There we go. Okay, so I need to add a demobilize, and mobilize now needs to take a mock log. So these ones need to change as well, don't they? So let's give it what it needs. Arc new, and then pass it to both. Clone. Thank you for the follow. Hey there, Buff Seagull. Always use sequential consistent unless you really need performance. I don't, so we're just because we're inside the test, it doesn't really matter too much. Oh, did I forget to say hello to a few people? Nuffly was asking what Git client is that, and yeah, it is Git Cola. But I forgot to say hi. That was a while ago. And Garrett. Garretosk 8CR. Greetings from Costa Rica. Oh, greetings from Southern California. I don't know how much longer I'll be streaming because I have to cook dinner. So, let me think about this. Yeah, I'm going to barely get started with this, aren't I? I have a lot of groundwork to cover, too. And it's, what, almost 7 hours? I can feel my brain slowing down. Okay, so yeah, I need to go back to server, and I need to say this requires now a log, which is a arc. For now, it's just arc log, right? Oh, thank you for the 10 bits. I had to cook it and then enjoy it, and then hopefully the kids like it too. Okay, so arc is use standard sync arc. Log is from the or crate. Yes, okay. So then we're not doing anything with that log yet, so we'll be able to pass this with flying colors, won't we? What's wrong here? Oh, that's a trait. So it's I can do that, correct? And then public function demobilize doesn't really need to do anything. We're just satisfying the minimum constraints here. This needs to be mutable. All right, given that, we should pass already. Not yet implemented. Oh, I forgot to do the drop. Drop needs to do self.dropped.compare exchange. Is there an easier way if I don't need the value out? Like, is there a store? Oh, there is a store. Store. True. Ordering sequential. Excellent. Run the tests. Pass and pass. Nice. So this will become important later. Basically, this makes sure that demobilize should drop the log that we gave it when we mobilized. Right now, we drop it immediately, but later we'll need to make sure that we actually release it as teardown, successful teardown. You're going to have dinner too. I don't even know what we're going to eat for dinner yet. I haven't even thought about it because I've been doing this work all day. Another thing you need to do is rewatch Fedor Picus' CPPCon videos. He goes into depth about atomics, memory ordering, and CAS. Yeah, that stuff's a really deep subject, right? Okay, maybe I have time for a couple more unit tests. Advance time to just before election timeout. What is this for? I don't know why. Oh, that's not even a test. I'm not even looking at the right place. Sorry. Gotta look at actual tests. Persistent state released on demobile. Okay, so actually there's just 2 more of these ones. I don't need to worry about scheduler because we're going to have an internal scheduler, I think. We don't need an external one. Although, actually, maybe I will have one because an external scheduler lets me mock time. Which I will want to have because I want to test things like timeouts without actually running the real-time clock. So I think we want those the interface actually, yeah. But I can have a default implementation of scheduler just built in then. Okay, so then that goes here. Test. If you're wondering why I'm copy-pasting code, it's because I already have the implementation of Raft in C++ that works, as far as I know, and I'm porting it to Rust today. Okay, so the same kind of thing, right? Actually, this is going to get really tedious. For these tests that don't care about the mocks, what if I just make a helper here? Function mobilize server. Server. Mutable reference to a server. And then I just do the log part. It doesn't even need to clone it, right? You can just make a new one. Like that. And then I can just say server new, mobilize server, server twice. That should be capitalized. Most of the time you don't care about the ordering, yeah. You just want done. Yeah, basically I'm just doing it so that the server is allowed to take the log and send it to another thread and drop it at some point later from a different thread. But it needs to do it by the time demobilize returns. So we just check to make sure that after demobilize finishes, that when it got dropped by that at that point. All right, so then what's next? Oh, this needs to take a reference, mutable reference. All right. These ones are going to be special that we're going to have to mobilize directly. That's fine. Yeah. Okay. Same thing. Same kind of thing here. Only I need another mock and I need another interface. So it's for persistent storage, right? So I have log persistent storage. You probably use persistent storage. New module persistent storage.rs. It's going to look a lot like log. It's going to be mostly empty. All right, and then back in common, I'm going to use it. Use crate persistent storage. Okay, and then I'm going to have a mock version of it. I'm already regretting dumping all my mocks here, but that's okay. Oops. Persistent storage. What's wrong here? Conflicting traits. Wait, what? Did I? Oh, I messed up, didn't I? I did too much. This should be log there. All right. Okay, so then basically it's a copy of the other mock. So then here though it's persistent storage. Okay, and I care about this one's dropped this time. Mobilize it, so we have to pass both of them now. And then make sure it wasn't dropped. So that means that this has to also use it too. And we need it here. It's a dependency injection. Which means I'm going to need it up here too. Which is fine, we can do that. So we can add that to there. It's going to get a little crowded, but that's okay. Okay, see ya, Garriott. Or Garritoskate. Alright. Oh, I forgot up here. Yeah, I forgot this. Arc new around that. That goes there. Right, just run. You know what I'm missing? I'm missing a run all tests button. Can I do that from here, though? Yeah, with this format, I'm missing a run all tests button. I'm tempted to put them into a submodule just to get that button. Okay, so what else? Scheduler. Yeah, so that's the third dependency. I think at this point I don't need to copy from the C++, I can just paste here, right? I keep hitting the wrong button. Copy, paste. This is scheduler. Mock scheduler. Scheduler. And you know the drill. We're going to pass in a third dependency now. Mock scheduler. Okay, which means I need it in all the other tests because I'm a glutton for punishment. No. That's not the real reason. Really, if I have enough dependencies, I probably should just put it into a structure, shouldn't I? Yeah, I'll probably come back here and put them into a structure, but right now I'm not going to worry about it so much. I'll come back and clean it up later. Okay, another one up here. With an arc new this time. Okay, and then I need top level, I need scheduler. And I need a pub use scheduler. And I need a new module called scheduler.rs. Pub trait scheduler. Empty for now. Okay, and then back in server, I need scheduler here. And I need scheduler here. Arcdyne scheduler. And I need a mock scheduler. Mock scheduler. All right, run that test. I want to find a stopping point after I do something significant, because all this seems like boilerplate to me to test, to make sure that the dependency injection will be checked for doing the same thing. Okay, so Server does not retransmit too quickly. Okay, here we go. Here's a real test. In this scenario, server 5 is a candidate and receives one less than the minimum number of votes required to be a leader. Once server 2 has not yet cast their vote. 5 would retransmit a vote request to server 2, but it should not do so until the retransmission time has elapsed. So that's the candidate we're voting for. What is this? Oh, 11 is voting for us. 6 and 7 are voting against. 2 hasn't voted yet. The candidate votes for itself, right? So that's inherently there. But I'm not going to modify the code. So it's basically a tie vote waiting for 2. So we mobilize the server. We wait for... We basically mock an election timeout. And then we mock that servers 6, 7, and 11 vote, and only 11 votes for, 6 and 7 vote against, 5 is voted for itself, so it should be a tie. Then we advance to all the way up to the RPC timeout right before that and wake up the scheduler, and we should make sure it did not send any message. Yeah, okay, so that's one test scenario, although it's going to require a lot of pieces. I think I might want to hold off on these more complex test cases until I actually have more of the stuff in there. Okay, this one will require that we be able to receive and append entries message. Yeah. This might be a stopping point for me because I got to cook dinner. I just need to figure out what am I going to do when I come back to this. What about the elections tests here? Okay, maybe start with this because all we need to do is mock the scheduler and then be able to receive messages. This is using a common test framework fixture here where we basically are advancing the clock, right? No, we're not even advancing the clock. We're making sure that we're waiting on a future basically, and make sure we didn't get any messages or what it tells us if we got a certain number of messages, right? Result is that the messages we waited for arrived. Okay, so all right, I get it. You wrote a little crate to mock an instant? I don't even know what an instant is. Oh, instant is a measurement of time in Rust, right? I'm probably going to want something like that. Instant. There we go. It's a time instant. Measure of a monotonically non-decreasing clock. I might need to actually study this before I get too much into my scheduler interface. Instant now. And then you can do elapsed. Yeah. Actually, this is probably what I want to mock, right? Well, hold on. I think the scheduler in my C++ is a little bit more than that, right? Let's see what it had. iScheduler. Where are you? I don't have an iScheduler? How do I set a scheduler then? Oh, I had a separate crate for that. Here it is. So you could get an underlying clock. That would be kind of like instant. And you could set it. And you could set callbacks and cancel them. And you could force it to wake up. And that was for testing. Okay. Yeah, I need to think about what I'm going to do here. So I don't think I have any more work. Thank you for the follow. I don't think I have any more work today to do. I need to do some thinking and research to figure out, like, basically what the API in scheduler looks like. And once I figure that out, then I can start thinking about some of these tests, like that simulate time advancing and then making sure that messages sent are what we expect, depending on the state of the server and all that. So, yeah, I got to get the scheduler stuff out of the way, and then I can start exploring like how the server reacts to its state combined with the passage of time. So I gotta end here. So let's see. I'm hopeful that there's someone streaming right now, Rust, but you never know. Team Rust Stations. Who's streaming Rust? Just me. Okay. How about people I'm following? Oh, I haven't rated Calocreation in a while. He rated me the other day, right? I think he did. Let's talk to Calocreation. So Calocreation, very entertaining streamer. He is in the same live coders team I'm in. He does a lot of web dev. He does a lot of work on his own overlay. He is somewhat of a variety streamer as well. He does a little bit of poetry. So hopefully you enjoy his channel. And I should be back tomorrow. I probably am not going to stream again tonight though. Yeah, and I'm not going to be here on Thursday. So let me start this raid going. So everybody, I hope you have a great rest of your day or your rest of your evening, and I'll see you next time, okay? Thanks for being here. Hope you enjoyed it. Take care now. Bye. Bye-bye.